They say there was a night when the sky itself turned against us. Imagine a small band of humans huddled around a dying fire 70,000 years ago, listening as strange lights burn across the heavens and the ground trembles like a living thing. By morning, the forest they knew is gone, the animals scattered, the rivers poisoned with ash. Yet from this terror, something impossible awakens behind their eyes. A new kind of sight, a mind that can remember, imagine, and remake the world. Tonight on Moonlight Science, we trace the moment when humans suddenly changed 50,000 years ago, when a fragile African primate became a planetary force, and will follow a single genetic whisper, passed down through fire and famine, to a revelation that will only make sense in the final minutes of this journey. Before we can understand what changed in us, we have to step back into a world where we were not alone. Picture Earth 100,000 years ago, under a colder sun and a heavier sky. Ice sheets grind slowly over northern continents, sculpting mountains into bare bone and locking oceans into frozen walls hundreds of meters high. Between these glaciers, in the narrow belts of forest, grassland, and steppe that remain, live many kinds of humans, not just our own. To the west and north, in Europe and Western Asia, Neanderthals move like shadows through spruce and birch, their heavy footprints pressing deep into snowdrifts. They are powerfully built, with barrel chests, thick limbs, and faces that project forward beneath low, strong brows. Their brains are as large as ours, sometimes larger, packed into skulls adapted to cold air and hard lives. In high Asian plateaus and the deep valleys of Siberia, another branch of humanity leaves only the faintest trace. A child's tooth, a sliver of finger bone, and a ghostly imprint in our genes. We call them Denisovans, but that is a modern name for a people who knew the sting of alpine winds long before any of us. Their features, their languages, their songs are gone, but their legacy lingers silently in the DNA of people from Tibet to Melanesia. On Flores, in Indonesia, a tiny species, Homo floresiensis, the so-called hobbits, hunts pygmy elephants and giant storks with stone tools, their short bodies and grapefruit-sized brains defying our assumptions about what intelligence must look like. And across Africa, our own birthplace, the picture is even more complex. Here live not just Homo sapiens, but likely other archaic hominins we barely know by name. Genetic signals whisper of ghost populations, human cousins who interbred with our ancestors, then vanished without leaving a single clearly identified skeleton. In this crowded world, our species is just one experiment among many. We call ourselves Homo sapiens now, wise man. But back then there is no reason anyone would have chosen us as the future. Neanderthals shape beautiful stone tools, control fire with expert ease, and hunt bison and woolly rhinoceroses in coordinated drives. In caves from Shanidar to La Chapelle-aux-Saints, skeletons with crippling injuries show signs of care, broken bones healed crooked but strong. This is not brute savagery. It is a tough, enduring social world. Across Africa, early Homo sapiens hunt antelope on open savannas, gather tubers in gallery forests, and comb tidal flats for shellfish. They shape tools and wield fire against predators, just as their cousins do in Europe's frozen valleys. If you could follow one of these hunters for a day, you might be startled by how familiar their intelligence feels. They problem solve. They cooperate. They remember. Yet for all this shared humanity, something is still missing. No one has built a city. No one has carved a myth into stone that will last for tens of thousands of years. There are tools, but not yet the dizzying variety that will one day fill museum cases. There is art in its infancy. perhaps a scratched pattern here, a pierced shell there, but not yet the great painted vaults of Chauvet or Lascaux. From a distance, no one species looks destined to dominate. The savannas and steppes, forests and coasts, all hold their own versions of people, each with their own ways of knowing the world. This is the deep time stage on which our story begins. A multipolar human planet, a family tree still full of living branches. The question that will drive our journey sits here, unsolved, in the cold air between these different fires. What happened that set one of these humankinds, ours, on a trajectory that would reshape the entire Earth, while all the others faded into silence? To find the answer, we must travel deeper into time and further into the continent where our story truly begins. Africa, 300,000 years ago, is not the stable cradle we might imagine. It is a restless giant, breathing in rhythms of rain and drought, expanding its green lungs and then contracting them into parched brown deserts. Savannas stretch endlessly under blazing skies, then flood with seasonal rains that transform dusty plains into shimmering wetlands. Forests advance and retreat like tides measured in centuries. Lakes swell to inland seas, then shrink to muddy puddles surrounded by the bones of hippos and crocodiles. This is the forge in which our species is hammered into existence. The earliest faces that look unmistakably like ours emerge from this turbulent landscape. At Jebel Irhoud in Morocco, skulls dating to around 300,000 years ago show a striking mosaic of features. The brain cases are elongated, still somewhat archaic, but the faces are hauntingly modern. Flattened with smaller brows and delicate cheekbones, they could almost pass in a crowd today. Further south and east, at Omo Kibish in Ethiopia, fossils from around 195,000 years ago display even more familiar anatomy. The skulls are rounder, higher, the chins more pronounced. At Herto, also in Ethiopia, 160,000-year-old remains show people who are anatomically indistinguishable from us, their skulls polished and modified in ways that suggest ritual treatment of the dead. These scattered fossils tell us something crucial. Homo sapiens did not spring fully formed from a single Garden of Eden. There was no one birthplace, no single tribe from which all humanity descends. Instead, our species emerged across the vast African continent in a slow, patchy, interconnected process. Different populations in different regions developed modern features at different times, exchanging genes and innovations across thousands of kilometers through networks we are only beginning to understand. Genetic studies have revolutionized this picture. By analyzing the DNA of living Africans and comparing it to ancient genomes extracted from fossil bones, scientists have reconstructed a map of deep ancestry that looks less like a family tree and more like a tangled river delta. Populations split and merged, isolated for millennia and then reconnected, carrying new mutations and cultural ideas back and forth across the continent. Some groups hugged the coasts, harvesting shellfish and learning the rhythms of tides. Others followed great rivers inland, hunting antelope and gathering tubers in gallery forests. Still others clung to highland refuges when lowland savannas turned to uninhabitable desert. This fragmentation was not weakness. It was strength. When drought gripped one region, populations elsewhere survived and eventually recolonized the empty lands. When one group stumbled upon a better way to knap a stone or process a plant, that knowledge could spread along ancient trade routes and marriage networks. Africa's size and climatic volatility meant that our ancestors were constantly being tested, scattered, reunited, and tested again. Each cycle of isolation and reconnection shuffled the genetic and cultural deck, creating variation and opportunity for new combinations to emerge. The humans who lived through these cycles were not yet the world-conquering species we would become. They made tools, but their toolkits changed slowly over tens of thousands of years. They buried their dead, perhaps, but left little evidence of elaborate ritual. They gathered in small bands, followed the herds, and watched the stars wheel overhead without yet naming the constellations. But somewhere in this restless crucible, the raw materials for transformation were accumulating. The brains were growing more complex, the social networks more intricate, the cultural repertoire slowly expanding. Africa was not just our birthplace. It was the pressure cooker that would eventually produce a mind capable of remaking the world. And soon, that pressure was about to intensify in ways no one could have predicted. Then the sky fell. Around 74,000 years ago, on the island of Sumatra in what is now Indonesia, a mountain named Toba tore itself apart in one of the largest volcanic eruptions in the last 2 million years. The explosion was almost unimaginable in scale. Thousands of cubic kilometers of rock and ash blasted into the atmosphere, climbing higher than any modern aircraft can fly. The eruption column punched through the stratosphere, spreading a gray shroud across the entire planet. Ash fell like black snow on landscapes thousands of kilometers away, burying forests and poisoning water sources. The sun glimpsed through the haze, turned blood red, then disappeared entirely behind a veil of sulfuric particles. What followed was a volcanic winter. Sunlight dimmed for years, perhaps decades. Global temperatures plummeted. In Africa, already stressed by natural climate cycles, the effects were devastating. Droughts intensified as rainfall patterns shifted. Grasslands withered. The great herds of antelope and wildebeest that early humans depended upon dwindled and scattered. Forests retreated to isolated pockets. Water sources that had sustained generations dried to cracked mud. For the scattered bands of Homo sapiens clinging to survival across the continent, this was an apocalypse in slow motion. Genetic evidence written in our DNA tells the story of what happened next. When scientists analyze the genomes of living humans, they find a telltale signature, a dramatic lack of genetic diversity compared to other great apes. Chimpanzees, bonobos, even gorillas show far more variation in their DNA than we do. This points to a severe population bottleneck, a moment when our ancestors were reduced to perhaps as few as 10,000 breeding individuals. Some estimates suggest even fewer. The entire future of humanity hung by a thread thinner than a spider's silk. In these desperate times, survival was not random. The bands that made it through were not simply lucky. They were the ones who could think further ahead, remember more precisely, cooperate more effectively, and adapt more quickly. When familiar hunting grounds became barren wastelands, they had to imagine new strategies, recall distant water sources visited years before, and convince others to follow them into unknown territory. The cognitive demands of survival ratcheted upward with every failed hunt, every dry stream bed, every child lost to starvation. This is evolution's cruelest classroom. Catastrophe prunes the family tree with brutal efficiency, cutting away branches and leaving only those best suited to endure. The humans who emerged from the bottleneck carried genes and minds subtly different from those who perished. They were not yet fully modern in behavior, not yet painting caves or composing myths. But the neural architecture for these achievements was being refined under the harshest possible selection pressure. Some groups survived by retreating to coastal refuges, where shellfish and marine resources provided a stable food supply even when inland ecosystems collapsed. The shores of southern Africa, around sites like Pinnacle Point and Blombos Cave, show evidence of human occupation through the worst of these times. Here, people learned to read the tides, to harvest mussels and limpets, to exploit a resource base their inland cousins could not access. These coastal survivors carried with them not just genes for survival, but cultural knowledge. Techniques for finding food in lean times that could be taught to children and passed down through generations. When the volcanic winter finally lifted and the world began to warm again, the humans who stepped back into the recovering landscapes were changed. They were fewer, yes, but they were also forged by fire and famine into something new. The bottleneck had not destroyed humanity. It had concentrated it, distilled it, and prepared it for a transformation that was now tantalizingly close. The sparks were ready. All that remained was the kindling caught in the strangest of places, not in grand monuments or mighty conquests, but in the quiet darkness of coastal caves, on the garbage heaps of ancient shellfish feasts, in the idle moments between survival and sleep. The evidence is small, almost easy to overlook. A chunk of red ochre, ground smooth on one side. A handful of snail shells with holes drilled through their centers. A piece of stone no larger than a palm, its surface covered in carefully scratched, cross-hatched lines. These objects, recovered from sites like Blombos Cave, Pinnacle Point, and Sibudu in South Africa, are among the most important artifacts ever discovered. They are the first whispers of a mind that thinks in symbols. At Blombos Cave, overlooking the Indian Ocean, archaeologists unearthed pieces of ochre dating back 100,000 years. Ochre is an iron-rich pigment that produces vivid reds, yellows, and browns when ground into powder. Early humans collected it, processed it, and used it, but for what? The practical applications are limited. Some suggest body paint for sun protection or insect repellent. But the most intriguing pieces show something else entirely. Deliberate geometric patterns, crosshatches, and lines have been engraved into their surfaces. These are not random scratches from use. They are intentional marks, created by a mind that wanted to impose order on matter, to make the stone say something. Nearby, and at sites scattered along the southern African coast, archaeologists have found shell beads, tiny marine snail shells, each one carefully pierced with a bone awl or stone point, each one threaded onto a cord long since rotted away. These beads are at least 75,000 years old, and their implications are staggering. A bead is useless for hunting. It will not keep you warm or fill your belly. Its only purpose is communication. Worn around the neck or wrist, strung into a pattern, a bead announces something about its wearer. Identity, status, group membership, perhaps spiritual protection. It is a message that can be read without words, a symbol that carries meaning beyond its physical form. This is the threshold that separates us from every other creature that has ever lived. Other animals use tools. Crows bend wire into hooks. Chimpanzees fish for termites with sticks. But no animal looks at a shell and sees not a shell, but a marker of belonging. No animal grinds pigment and dreams of painting its body for a ritual that exists only in shared imagination. When a human drills a hole in a shell and threads it onto a string, something unprecedented is happening inside their skull. The object has become detached from its immediate reality. It now points to something else, an idea, a relationship, an invisible bond between people. At Sibudu Cave, researchers found evidence of complex compound tools, stone points hafted onto wooden shafts with carefully prepared adhesives made from plant gum and ochre. Creating these weapons required holding multiple steps in mind simultaneously, planning a sequence of actions toward a future goal. This is not just tool use. It is mental time travel, the ability to simulate tomorrow and work backward to today. These scattered sparks, a scratched stone here, a pierced shell there, may seem insignificant against the vast timescales of human evolution, but they represent a cognitive revolution in miniature, the first tremors of an earthquake that would eventually remake the world. Something was changing in the wiring of the human brain, in the connections between perception and meaning, between the eye and the imagination. The question now becomes, what exactly changed inside those skulls? And why did it happen to us and not to our cousins who still roam the frozen valleys of Europe and the misty highlands of Asia? The answer lies coiled in the double helix of our DNA, written in a language of 4 chemical letters that has been editing itself for billions of years. When scientists began comparing the human genome to those of our closest relatives, chimpanzees, bonobos, and eventually Neanderthals and Denisovans, they expected to find dramatic differences. After all, we build telescopes and write symphonies while chimps crack nuts with rocks. Surely the genetic gulf would be vast. Instead, they found something far more unsettling. We share over 98% of our DNA with chimpanzees. The differences that separate a poet from a primate are measured not in wholesale genetic reinvention, but in tiny tweaks, subtle adjustments to timing and expression that cascade into profound changes in how brains are built. One of the most famous of these tweaks involves a gene called FOXP2. Scientists first identified it by studying a British family afflicted with severe speech and language disorders across multiple generations. When the gene was sequenced, researchers discovered that humans carry a version with 2 amino acid changes not found in other great apes. FOXP2 is not a language gene in any simple sense. It does not contain the vocabulary of English or the grammar of Mandarin. Instead, it acts as a master regulator, switching other genes on and off during brain development, shaping the neural circuits that allow for the fine motor control of lips, tongue, and larynx required for speech. Intriguingly, Neanderthals shared our version of FOXP2. They too may have possessed some capacity for vocal communication. But having the hardware is not the same as running the software. Another crucial player is SIRGAP2, a gene involved in the development of dendritic spines, the tiny protrusions on neurons where connections form. Humans carry a duplicated, partially truncated version of this gene that appears to slow down brain maturation, extending the period during which neural connections can form and be refined by experience. This prolonged plasticity may be one reason human children take so long to reach adulthood compared to other apes. We trade speed for flexibility, spending years absorbing language, culture, and social knowledge that would be impossible to hardwire into genes alone. Beyond individual genes, the real magic lies in regulatory elements. Stretches of DNA that control when, where, and how much a gene is expressed. Small changes in these regulatory regions can radically alter brain development without changing the genes themselves. Imagine 2 orchestras with identical instruments but different conductors. The notes are the same, but the music that emerges is utterly different. Human brains appear to have been reorchestrated in ways that enhance connectivity between regions, particularly those involved in language, planning, and social cognition. The result of these accumulated changes was a brain capable of something no other brain on Earth could do: recursive thought. Recursion is the ability to embed concepts within concepts, sentences within sentences, plans within plans. It is what allows you to understand that the man who saw the dog that chased the cat is my neighbor contains nested relationships stretching back through multiple layers. This seemingly simple trick unlocks infinite expressive power. With recursion, a finite set of words can generate an infinite variety of meanings. Stories can contain stories. Futures can be imagined, debated, and revised before they happen. This biological substrate, the genetic switches, the regulatory fine-tuning, the extended plasticity, created a mind that could hold the past and future simultaneously, that could simulate other minds and imagine their perspectives, that could bind arbitrary sounds to abstract meanings and share those meanings with others. The machinery was in place. The engine was built. What remained was to turn the key and see what this new mind could do when it opened its mouth and began to speak. The key turned one evening, perhaps 70,000 years ago, beside a fire on an African savanna. We cannot know the exact moment, cannot identify the first speaker or the first words, but we can imagine the scene. Night has fallen. A small band huddles in the circle of firelight that keeps the darkness and its predators at bay. A woman, her skin painted with ochre, a string of shell beads at her throat, looks into the flames and begins to speak. Not in grunts or simple warning calls, but in structured, nested, recursive language. She tells the others what she saw today beyond the ridge. A herd of antelope moving north, a waterhole drying to mud, storm clouds gathering in the east. Then she does something extraordinary. She shifts tenses. She speaks of tomorrow, of the route they should take at dawn, of the place 3 days' walk away where her mother once found water in a drought. She conjures the past and the future into the present, pulling them out of her memory and imagination and placing them into the minds of her listeners through nothing but organized sound. This is the superpower that will change everything. Language is not simply a better communication system, an upgrade from pointing and miming. It is a technology for binding minds together, for creating a shared cognitive space where ideas can be stored, tested, and transmitted. When that woman speaks of the waterhole her mother found, she is moving knowledge across time. Her mother's discovery, made decades ago, does not die with her mother's body. It persists, encoded in words, ready to save lives in future droughts. Each generation can now inherit not just genes, but the accumulated discoveries of all who came before. Culture becomes cumulative. Around that same fire, language does other kinds of work. A young man complains about another hunter who took more than his share of meat. Names are spoken. Reputations are built or damaged. Gossip flows like water, carrying social information that determines who can be trusted, who should be shunned, who is brave, who is a liar. This may seem trivial, even petty, but it is anything but. In a world where survival depends on cooperation, knowing who keeps promises and who breaks them is a matter of life and death. Language allows groups to scale beyond the small face-to-face bands where everyone knows everyone. Through words, the actions of strangers can be judged, alliances formed, and cheaters punished even if you never witnessed their crimes yourself. Then there are the words that have no physical referent at all. Words like promise, taboo, spirit, and honor. These abstractions create invisible structures that organize behavior as surely as any physical wall. A promise is nothing you can touch, yet it binds action across time. A taboo against eating a certain animal or entering a sacred grove creates behavioral rules that an entire group will follow without needing constant enforcement. The concept of an ancestor's spirit watching from the shadows generates self-policing better than any human overseer could. Language allows humans to create shared fictions, gods, laws, nations, money, and then act collectively as if these fictions are real. This is not a bug. It is the feature that makes civilization possible. The selective advantage is overwhelming. A group that can share detailed plans, coordinate complex hunts, teach intricate skills through verbal instruction, and bind themselves together with oaths and stories will outcompete groups that cannot. Language turns a collection of individuals into a superorganism, a swarm intelligence that thinks with many brains. It is a cognitive net cast over the group, pooling memory and imagination. And once this net is woven, once words become the invisible infrastructure holding a society together, there is no going back. The talking apes have crossed a threshold from which no return is possible. They are no longer merely adapting to the world, they are beginning to remake it. But when exactly did this transformation happen? The question has sparked one of the longest-running debates in all of archaeology. For decades, scholars have argued over whether humanity's awakening was a sudden revolution or slow burn stretching back hundreds of thousands of years. The evidence, maddeningly, seems to support both sides. The case for revolution is dramatic and hard to ignore. Around 50,000 years ago, the archaeological record explodes. In Europe, Cro-Magnon people arrive bearing an arsenal of innovations that seem to appear almost overnight. Long, elegant stone blades struck from carefully prepared cores, bone needles for tailored clothing, intricate carvings of animals and human figures, elaborate burial sites with grave goods suggesting belief in an afterlife. And most spectacularly, the great painted caves like Chauvet and Lascaux, where horses gallop across limestone walls and lions stare from the shadows with such lifelike intensity, they seem ready to spring. This sudden efflorescence led some archaeologists to speak of a great leap forward, a moment when fully modern behavior switched on like a light in the minds of our ancestors. Yet the case for gradualism is equally compelling. The ochre engravings at Blombos are 100,000 years old. Shell beads appear sporadically across Africa and the Middle East as far back as 135,000 years. Early blade technologies emerge and then disappear, only to re-emerge tens of thousands of years later. Symbolic artifacts show up in one region, then vanish for millennia before appearing again elsewhere. If there was a great leap, why do we find these tantalizing precursors scattered across such vast stretches of time? The slow burn camp argues that modern cognition evolved gradually, flickering on and off in different populations, practiced unevenly, lost and rediscovered as climates shifted and populations contracted or expanded. The truth, as with most things in deep time, is more nuanced than either extreme. What we are witnessing is likely not a single event, but a threshold crossing, a tipping point. Imagine a long, slow accumulation of cognitive and cultural potential building over hundreds of thousands of years. Better brains evolve through the genetic changes we've traced. Language emerges and spreads unevenly. Small innovations appear in isolated groups but fail to take root, because populations are too sparse, too fragmented, or too stressed by climate catastrophe to sustain them. An elder who knows how to make beads dies before teaching the young. A group that carves symbols is wiped out by drought. The thread is broken, again and again. But after the bottleneck, something changes in the equation. Populations begin to recover and expand. Groups reconnect. Trade networks lengthen. The density of minds sharing a common symbolic vocabulary reaches a critical mass. Now, when someone invents a better blade technique or new way to trap fish, it spreads. When a storyteller crafts a powerful myth, it is remembered and retold across generations. Culture itself begins to evolve, not through genetic mutation, which takes tens of thousands of years, but through imitation, teaching, and innovation, which can happen in a single lifetime. This is the moment when culture escapes the leash of biology. For millions of years, evolution shaped behavior by sculpting brains. Now behavior begins to change faster than brains can. A human born in one generation can learn radically new skills, adopt new beliefs, and use entirely different tools than their grandparents, all without a single change to their DNA. The 50,000-year mark, then, is not when modern minds appeared, but when they reached a critical density and connectivity that allowed their collective intelligence to ignite. The Great Leap was not a lightning bolt from the sky. It was a slow-burning fuse that finally reached the powder keg. And when it did, the explosion would be visible from space. The explosion's first visible traces are found in the deepest, darkest places humans dared to go. Miles from daylight, beyond the reach of any practical campsite, in twisting corridors where the ceiling presses low and the air tastes of clay and time. Ancient artists crawled with flickering torches to paint the walls. Why? What drove them into the belly of the earth with pigments ground from ochre, charcoal, and manganese, to leave images that would outlast empires not yet dreamed of? In the Chauvet cave in southern France, discovered only in 1994 and sealed for 20,000 years, we find an answer that steals the breath. The walls explode with life. Lions stalk across the limestone in fluid motion, their shoulders bunched for the kill, their eyes cold and predatory. Rhinoceroses lower their massive horns. Herds of horses stampede in coordinated panic. The artists use the natural contours of the rock to give their subjects three-dimensional form, shading muscles with charcoal smudges, erasing and redrawing limbs to capture movement. This is not primitive scribbling. This is mastery. Halfway around the world, on the Indonesian island of Sulawesi, equally ancient hands pressed palms against cave walls and blew red ochre over them, creating ghostly negatives. Stencils of human presence that declare, "I was here. I existed. Remember me." These handprints, dating to at least 40,000 years ago, are among the most moving artifacts ever discovered. They are not images of the world, but images of the self reaching out across time, a message in a bottle thrown into the ocean of millennia. In Namibia, at a site called Apollo 11 Cave, archaeologists unearthed painted stone slabs showing what appears to be a therianthrope, a creature that is part human, part animal. It is 27,000 years old. Across continents and cultures separated by oceans and tens of thousands of years, the same impulse appears. The urge to make the invisible visible, to give form to the things that haunt the mind. These images are not decoration. They are technology, psychological tools as important as any spear or fishhook. When a hunter paints the bison, he will hunt tomorrow. He is rehearsing the kill in his mind, visualizing the approach, the throw, the strike. He is running a simulation, preparing his brain and body for the real encounter. When he paints the lion that killed his brother, he externalizes the terror, gives it a boundary, a shape he can look at and walk away from. The nightmare on the wall cannot follow him into sleep. By creating these external images, humans discovered a way to think outside their own skulls. The painting becomes a shared reference point, a place where minds can meet. The elder points to the bison on the wall and teaches the child where to aim the spear. The shaman gestures to the therianthrope and explains the dream journey to the spirit world. The cave becomes a theater, a classroom, a temple, a space where the collective imagination takes physical form. This is the birth of the external mind. For millions of years, everything a creature knew died with it. Now, knowledge could be carved in stone, painted on walls, sung in verses designed to be memorized. Ideas became objects. Memory became architecture. The inner world of dreams, fears, plans, and beliefs, once locked invisibly inside individual skulls, was now spilling out into the world, where it could be shared, debated, refined, and preserved. Culture was no longer trapped in flesh. It had found a way to live in stone, in pigment, in story, and in song. And once freed from the skull, it would never stop growing. The humans who emerged from these painted caves carried with them not just tools, but entire worlds built from shared imagination. They were walking libraries, living mythologies, and they were just beginning to understand the power they now possessed. The hands that painted those walls did not stop at art. The same cognitive fire that imagined lions on stone now turned to bone, flint, and wood with unprecedented creativity. The toolkit, which had remained relatively stable for hundreds of thousands of years, simple hand axes, scrapers, and cores, suddenly exploded into a dazzling array of specialized instruments, each designed for a specific task, each reflecting a mind that could plan many steps ahead and solve problems that didn't yet exist. Consider the blade. For most of human prehistory, tools were made by bashing one rock against another to produce sharp flakes. Functional, yes, but crude. Then, around 50,000 years ago, toolmakers began preparing cores with extraordinary care, shaping them into precise geometric forms, cylinders or cones, from which they could strike off dozens of long, parallel-sided blades. Each blade was thin, sharp along both edges, and standardized. This is mass production in miniature, a manufacturing process that requires holding a complex mental template and executing it with exacting precision. A single prepared core could yield 10 times more cutting edge than the old methods. Efficiency like this suggests minds capable of abstract planning and optimization. But blades were just the beginning. Humans began working with bone, antler, and ivory, materials that require entirely different techniques than stone. At sites across Europe and Asia, archaeologists find delicate bone awls, harpoons with backward-facing barbs designed to lodge in fish flesh, and needles so fine they could stitch hides into tailored clothing. That last innovation, the eyed needle, is easy to overlook, but it changed everything. With fitted garments sewn tight against the skin and insulated with fur, humans could survive the killing cold of Ice Age winters. The needle opened the door to the Arctic, to Siberia, and eventually to the Americas. Even more remarkable are composite tools, weapons and implements made from multiple carefully shaped parts joined with bindings, adhesives, and hafting. Tiny stone microliths, geometric blades smaller than a fingernail, were set into grooves along wooden or bone shafts to create razor-edged projectiles. Spear points were attached to shafts with pine resin mixed with ochre and beeswax, a recipe that had to be heated to precise temperatures and applied at exactly the right moment. These are not objects you stumble upon by accident. They are the products of deliberate experimentation, failure, refinement, and teaching. And that is the key. Making a microlith-tipped arrow or bone harpoon with recurved barbs requires skills that take years to master. A child learning to knap stone will ruin hundreds of cores before producing a single usable blade. This knowledge cannot be encoded in genes. It must be taught, demonstrated, corrected, and practiced. The explosion in tool diversity is therefore also an explosion in teaching culture. Master craftsmen passing techniques to apprentices, communities developing shared standards for what a good blade or harpoon looks like, traditions of tool-making that become markers of group identity. These tools did more than make life easier. They shattered ecological boundaries. With tailored clothing and efficient hunting weapons, humans moved into frozen tundras where no primate had ever lived. With harpoons and fishhooks, they exploited rivers, lakes, and coastlines with new intensity. With fire-hardened digging sticks and grindstones. They processed plants once thought inedible. Every new tool was a key that unlocked a new environment, a new food source, a new way of surviving. Humans were no longer adapting to their environment through slow genetic change, waiting for natural selection to reshape their bodies over millennia. They were adapting through culture, inventing their way into new niches in mere generations. The toolkit revolution turned a tropical African ape into the ultimate generalist, a species that could live anywhere, eat anything, and solve any problem the world threw at it. And soon, that generalist would prove it by walking to the ends of the earth. But tools alone do not explain what happened next. Scattered across archaeological sites from this period, researchers find objects that tell a different story, one not of isolated bands scraping by in hostile landscapes, but of connections stretching across hundreds of kilometers, invisible threads tying distant groups into networks of exchange that would reshape the human world. Pick up a marine shell found 300 kilometers from the nearest coast, buried in a campsite high in the mountains. Or a blade made from obsidian, volcanic glass, whose chemical signature matches a volcano 3 mountain ranges away. Or a lump of red ochre whose mineral composition reveals it was mined in a valley no one at this site has ever seen. These objects are messengers from distant places, carried by human hands across vast distances in a web of exchange we are only beginning to understand. This is the fossil evidence of trade networks, and they are far older and more extensive than anyone once imagined. By 50,000 years ago, materials are moving hundreds of kilometers from their sources, passing through multiple hands, crossing linguistic and cultural boundaries. A coastal group harvests shells, pierces them into beads, and trades them inland for high-quality flint. That flint travels north in exchange for ochre. The ochre moves east in return for furs or dried meat. Each exchange is a node in an expanding network, a handshake across distance. But to call this simply trade misses the deeper significance. These networks are not just moving objects. They are moving information. When a stranger arrives at your fire carrying shells from a coast you've never seen, they bring more than jewelry. They bring news. Where the herds are moving, which valleys have water, which groups are friendly and which are dangerous. They bring techniques. A new way to have to spear, a better recipe for adhesive, a song that helps you remember the stars. In an age without writing, travelers were living libraries, and every exchange was a download of data. The networks also moved something even more precious: genes. Isolated populations, no matter how clever, face the crushing mathematics of inbreeding and genetic drift. But groups connected by trade are also connected by marriage alliances. A woman leaves her birth group with a dowry of beads and knowledge, joining a distant band and weaving her lineage into theirs. This flow of genes keeps populations healthy, diverse, and adaptable. Perhaps most importantly, the networks functioned as insurance against catastrophe. When drought struck one region, groups could call on distant trading partners for aid, migrating temporarily or receiving emergency supplies of food. These relationships were not casual. They were maintained through cycles of gift-giving, storytelling, and ritual that built trust and obligation across generations. Reputation became currency. A group known to honor its debts and reciprocate generosity could draw on a safety net spanning thousands of square kilometers. A group that cheated or hoarded faced isolation and death. This is where language, symbolic thought, and social cognition converge into something powerful. Trust between strangers requires shared symbols, a bead that signifies alliance, a pattern of ochre that marks kinship, a story that establishes common ancestry. Maintaining reputations across distance requires gossip, memory, and the ability to keep track of who owes what to whom. The human mind, with its obsessive focus on social relationships and fairness, was perfectly designed for this kind of network building. These Stone Age trade routes are the first faint sketches of the globalized world we inhabit today. They prove that humans were never isolated survivalists, but deeply social creatures whose strength lay in connection. The networks accelerated innovation. A good idea in one valley could spread across a continent in a generation. They increased resilience. No single disaster could wipe out the web. And they foreshadowed the future when those threads of shell and obsidian would be replaced by roads, ships, fiber optic cables, and satellites. But the fundamental human drive to connect, exchange, and trust would remain exactly the same. The networks of shell and obsidian were only possible because of a more fundamental transformation happening inside human skulls. The brain that could track debts across distance, remember reputations, and trust strangers was a brain that had become saturated with other people. We carry, each of us, an entire village in our heads. Anthropologist Robin Dunbar discovered something remarkable when he studied primate societies. There is a direct correlation between the size of a species' neocortex, the wrinkled outer layer where higher thinking occurs, and the size of its typical social group. Lemurs with their small neocortices live in groups of 5 or 10. Chimpanzees, with larger brains, manage communities of 50. But humans? Our massively expanded neocortex allows us to maintain stable social relationships with about 150 individuals. This is Dunbar's number, the cognitive ceiling on our social world, and it appears everywhere. In hunter-gatherer band networks, military company sizes, even modern social media engagement patterns. But what does it mean to know 150 people? It means far more than recognizing faces. For each person in our social sphere, we maintain a complex mental file. We know their temperament, quick to anger or slow to trust. We remember their history, who they've helped, who they've betrayed. We track their relationships, who they love, who they fear, who owes them favors. We model their knowledge, what they know that we don't, what we know that they don't know we know. This is a staggering cognitive load. No other animal tracks information at this depth about this many individuals. The machinery that makes this possible is unlike anything else in nature. Mirror neurons fire both when we perform an action and when we watch someone else perform the same action. They allow us to feel what others feel, to wince when they are hurt, to yawn when they yawn. Theory of mind circuits let us simulate other people's mental states, to step inside their thoughts and see the world through their eyes. We don't just observe behavior. We reverse engineer the beliefs and desires that drive it. This social superpowers transforms every interaction into a chess game of invisible complexity. When a hunter returns to camp empty-handed, we don't just see failure. We simulate his shame, predict how it will affect his status, anticipate who will mock him and who will offer comfort, and calculate how our own response will be interpreted by others watching. Every social moment unfolds across the multiple dimensions. What happened, what people think happened, what people think other people think happened, and so on into dizzying recursive loops. But this gift comes with a curse. A brain that can simulate rejection can fear it before it happens. We are the only species that can lie awake at night, replaying a social mistake from years ago, feeling the shame as fresh as if it just occurred. We are the only species that can be tortured by imagining what others think of us. Anxiety, depression, and social phobia are the prices we pay for our social genius. The fear of ostracism may be the most powerful force in human psychology. In the small bands where we evolved, exile meant death. No single human could survive alone against predators, weather, and starvation. Our brains evolved an exquisite sensitivity to social rejection, a radar constantly scanning for signs that we might be pushed to the group's edge. This terror drives both our most noble and most terrible behaviors. We cooperate, share, and sacrifice to maintain our place in the group. But we also conform, suppress doubt, and turn viciously on those marked as outsiders. The social brain makes us capable of breathtaking altruism, risking our lives for strangers, sharing our last food with the hungry. But it also makes us capable of cruelty that no wolf or shark could conceive. Systematic humiliation, coordinated genocide, the weaponization of shame. We are the only species that can destroy someone not with teeth or claws, but with whispered words that turn a community against them. The same cognitive tools that bind us together can tear us apart. And both capacities were about to be tested as humans faced their next great challenge. The social brain that could simulate human minds so expertly made a fateful error. Or perhaps it was not an error at all, but the next step in our evolution. It began to see minds everywhere, not just in the faces around the fire, but in the lightning that split the sky, in the river that gave or withheld fish, in the sickness that stole children in the night. This was not stupidity or primitive confusion. It was the hyperactive agency detection that had kept our ancestors alive. The rustle in the grass might be wind, but if you assume it's wind and it's actually a leopard, you die. If you assume it's a leopard and it's actually wind, you waste some energy running. Natural selection favored the paranoid, those who saw intention lurking everywhere. But once human minds could model complex intentions, simulate beliefs and desires, and imagine invisible mental states, this hair-trigger agency detection took on a new dimension. When lightning struck a tree near the camp, killing a young mother, the human mind could not accept randomness. The social brain, trained to look for intention behind every action, searched for an agent. Who was angry? What had the woman done? The lightning became a spear thrown by an invisible hunter, a sky being whose motives could perhaps be understood, negotiated with, appeased. When the rains failed and the herds disappeared, it was not mere weather patterns, but withdrawal of favor by the powers that controlled the rain. When a child burned with fever, thrashing in delirium, speaking to people who weren't there, the explanation was obvious. Invisible beings had entered her body or called her spirit away. Into this gap between cause and effect, between what humans could control and what remained mysterious, stepped the first gods. Not the elaborate pantheons that would come later, but simpler spirits, of places, of forces, of the dead who surely could not simply cease to exist. The grandmother who knew every healing plant, every story, every trail, could not just vanish when her body stopped moving. She must persist somewhere, watching, perhaps helping, perhaps angry at being forgotten. The evidence appears in how the dead were treated. At Chauvet Cave in Israel, 90,000 years ago, bodies were deliberately buried with red ochre and shell beads. At Sungir in Russia, 34,000 years ago, an elderly man and 2 children were interred with thousands of ivory beads, fox teeth, and mammoth ivory spears that would have taken hundreds of hours to create. These are not mere disposals of corpses. These are preparations for a journey, equipment for another world. Rituals crystallized around these beliefs. If the sky being was angry, perhaps it could be calmed with offerings. The best portion of the hunt burned in the fire so the smoke could carry it upward. If the ancestors were watching, they must be honored with songs, stories, and careful observance of the traditions they established. If the river spirit controlled the fish, then specific words must be spoken, specific taboos observed, or the nets would come up empty. This was not superstition, but technology, social technology. Shared beliefs in invisible powers did something remarkable. They aligned behavior across the group, even when no human enforcer was watching. The hunter alone in the forest, tempted to eat the portion meant for sharing, remembered the ancestors watching and restrained himself. The young woman gathering berries followed the taboo against harvesting from the sacred grove, not because anyone would know, but because the spirits would know. Religion was born not as an explanation for the universe, but as a survival strategy, a way to manage uncertainty, coordinate groups, and maintain social norms across time and space. The same imagination that could picture tomorrow's hunt could picture worlds beyond death, beings beyond sight, and moral laws written not in stone, but in the very fabric of existence. And with this invisible architecture in place, humans were ready to attempt something unprecedented, to leave Africa entirely and walk into the unknown world beyond. Armed with spirits to guide them and stories to bind them, carrying toolkits refined over millennia and languages that could describe lands they had never seen. Small groups of humans began to edge toward the boundaries of the known world. The African continent that had birthed and shaped them was about to become just the first chapter in a much longer story. What drove them to leave? Perhaps it was pressure from growing populations, perhaps following herds that wandered too far, perhaps simple human curiosity. The same cognitive itch that made them crawl into dark caves to paint now pulled them toward distant horizons. The first steps out of Africa were not a single exodus, but multiple probes across tens of thousands of years. Genetic breadcrumbs in our DNA tell the story. By analyzing mutations that accumulate at predictable rates, scientists can trace our pathways like following footprints in molecular sand. The earliest successful exit, around 70,000 to 60,000 years ago, saw small groups, perhaps as few as 1,000 individuals, cross the narrow straits at the southern tip of the Red Sea into Arabia. The sea level was lower then, the distance shorter, but it still required planning, coordination, and likely simple rafts or boats. This was not stumbling accidentally into new territory. This was intentional exploration. From Arabia, they spread with astonishing speed, archaeologically speaking. Following the coastlines where shellfish and fish provided reliable food, they moved east along the Indian Ocean rim. Within perhaps 10,000 years, their descendants had reached India, Southeast Asia, and the scattered islands of Indonesia. Each new landscape demanded innovation. The monsoon patterns of India were unlike anything in Africa. The dense rainforests of Southeast Asia required new hunting strategies. The coasts provided bounty, but also cyclones and tsunamis that could erase entire groups without warning. Then came an achievement that still defies full explanation. By 50,000 years ago, possibly earlier, humans had crossed the water gaps to reach Australia, a journey that required multiple sea crossings out of sight of land. These were not accidental driftings. They had to plan the voyage, build seaworthy vessels, carry fresh water and food, and make the choice to sail toward a horizon that might hold nothing. When they landed on those strange shores, they encountered a fauna like nothing that existed in Africa. Giant wombats, massive flightless birds, carnivorous kangaroos. Yet they adapted, survived, and thrived, developing fire-stick farming techniques that would reshape the entire continent's ecology. Meanwhile, other groups pushed north and west. Some crossed the Sinai into the Levant, following game into the grasslands of Central Asia. Others moved up through the Caucasus into Europe. Each route was a gauntlet. The Neanderthals still controlled much of Western Eurasia, adapted to those landscapes over hundreds of thousands of years. The advancing modern humans were tropical newcomers facing bitter winters, unfamiliar prey, and established competitors. Many groups must have failed, freezing in sudden blizzards, starving when herds moved unpredictably, or falling to diseases carried by their Neanderthal cousins. But the cognitive toolkit that had emerged in Africa proved remarkably adaptable. Language allowed rapid transmission of local survival knowledge. Symbolic culture let groups maintain identity and cohesion even when scattered. Trade networks meant that innovations, a better cold-weather clothing design, a new hunting technique, could spread faster than genes. The spirits and ancestors carried in stories provided psychological comfort in terrifying new environments where every shadow might hide an unknown predator. The genetic and archaeological evidence reveals not a triumphant march, but a desperate, tenacious crawl across the planet. Yet within perhaps 40,000 years of leaving Africa, humans had colonized every continent except Antarctica. We had become the most widely distributed large mammal on Earth. And everywhere we went, we carried the cognitive revolution with us. Not just in our genes, but in our minds, our tools, our stories, and our endless capacity to imagine new worlds and then make them real. The new worlds humans entered were not empty. In the flickering shadows of European caves, around the fires of Asian valleys, other kinds of humans watched the newcomers arrive. These were not animals to be hunted or avoided, but beings uncannily like ourselves. Walking upright, wielding tools, tending fires, caring for their dead. The meetings that followed would leave traces in our bones, our genes, and perhaps our nightmares. For these encounters determined which version of humanity would inherit the Earth. In Europe, modern humans met the Neanderthals face to face. These were not the brutish cavemen of popular imagination, but sophisticated survivors who had mastered the harsh Ice Age landscapes for over 300,000 years. They were shorter than the African newcomers, but more powerfully built. Their bodies thick with muscle, their bones dense as stone. Their brains were actually larger than ours on average, though shaped differently. Elongated where ours are globular, with less developed frontal regions but expanded areas for vision and body control. They made complex tools, created art, buried their dead with flowers, and cared for injured companions who could no longer contribute to the hunt. What happened when modern human met Neanderthal? The evidence suggests every possible form of interaction. At some sites, the two populations lived in the same valleys for thousands of years, their tool styles remaining distinct, suggesting limited contact. At others, the technologies blur together, as if ideas were being exchanged across species lines. And in our very genes lies proof of the most intimate contact of all: interbreeding. Every human alive today whose ancestors left Africa carries between 1% and 4% Neanderthal DNA, the genetic echo of ancient liaisons between species. These were not casual encounters. For successful interbreeding to leave traces in our genomes, the hybrid children had to survive, be accepted by one group or the other, and reproduce successfully themselves. Picture a Neanderthal woman joining a modern human band, or a modern human male accepted into a Neanderthal family. The social negotiations, the communication across different minds and possibly different languages, the crossing of species boundaries that must have seemed as profound then as they do now. All of this happened repeatedly across Europe and Western Asia. In the high mountains of Asia, modern humans met another cousin, the Denisovans. We know frustratingly little about them: a finger bone, a few teeth, and genetic ghosts in living populations. But those ghosts tell remarkable stories. Tibetan highlanders carry a Denisovan gene variant that allows them to thrive at altitudes where others gasp for air. Melanesians and Aboriginal Australians carry up to 6% Denisovan DNA. These adaptations suggest the Denisovans had mastered environments from frozen Siberian valleys to tropical Asian islands. And when modern humans arrived, they didn't just compete. They learned, they borrowed, they merged. There were others too, shadows in our genome. African populations carry traces of archaic humans who have left no fossil remains we can identify. These ghost populations interbred with our ancestors, contributing genetic diversity that may have provided crucial adaptations to disease or climate. Each encounter was a roll of the evolutionary dice, a test of compatibility and competition. Yet within 30,000 years of modern humans spreading across Eurasia, all the other human species were gone. The last Neanderthals vanished from Gibraltar around 28,000 years ago. The Denisovans disappeared from the record. The hobbits of Flores went extinct. What happened? Direct violence seems too simple. There's little evidence of systematic warfare. Disease is possible. Modern humans from tropical Africa may have carried pathogens that devastated populations with no immunity. Climate change certainly played a role. The wild temperature swings of the late Pleistocene stressed all populations. But perhaps the crucial difference was cultural. Modern humans had symbol-saturated minds, complex languages, and cumulative culture that allowed rapid adaptation. While Neanderthal tools changed slowly over millennia, modern human technology evolved within generations. Our ancestors didn't need to be smarter. They just needed culture that could evolve faster than genes, and networks that could share innovations across continents while other human species remained locked in regional traditions. In the end, we are the last humans standing, not because we were the strongest or the smartest, but because we were the most connected. The last of our cousins had barely faded into extinction when the world itself turned against us. Around 26,000 years ago, the climate began its final descent into the deepest freeze of the Ice Age. The last glacial maximum, ice sheets that had been advancing and retreating for millennia, now surged forward with terrifying finality. In North America, the Laurentide ice sheet grew to over 2 miles thick, pressing down with such weight that it deformed the Earth's crust. In Europe, Scandinavian ice merged with alpine glaciers, leaving only a narrow corridor of frozen steppe between walls of white death. Sea levels dropped by over 400 feet as the oceans themselves were locked into continental ice. Britain became a peninsula. Asia connected to America. The world's coastlines, where so many humans had thrived, were now barren plains stretching to horizons that had once been sea floor. For the humans who remained in northern latitudes, survival required a complete reimagining of existence. At sites like Sungir in Russia and Dolní Věstonice in the Czech Republic, we find evidence of adaptations so ingenious they take the breath away. Houses built from mammoth bones, skulls for foundations, tusks for arches, shoulder blades for walls, creating structures that could withstand winds that would shred modern tents. Inside, hearths burned constantly, not just for warmth, but for light during the endless Arctic nights, when the sun barely scraped the horizon. The clothing from this period represents engineering that wouldn't be improved upon until the Industrial Age. At Sungir, burials reveal garments decorated with thousands of ivory beads, each one representing an hour of careful work. But beneath the decoration was serious technology. Layered furs with the hair facing both inward for insulation and outward for water resistance. Hoods designed to trap breath warmth around the face. Mittens attached with sinew cords so they couldn't be lost in blizzards. Needles from this period are so fine they could work with thread made from split tendons, creating seams tighter than many modern machines produce. Food required even more planning. Summer's brief bounty had to sustain bands through 9 months of winter. Storage pits dug into permafrost became refrigerators that could preserve meat for months. But storage alone wasn't enough. Humans had to predict the movements of migrating herds, coordinate massive communal hunts, and process thousands of pounds of meat before it spoiled. At sites across Eastern Europe, we find evidence of mammoth kill sites where entire herds were driven over cliffs or into boggy ground. These weren't opportunistic kills, but carefully planned operations requiring scouts, drivers, butchers, and processors working in precise coordination. The cognitive load of this lifestyle was staggering. Success required mental models of vast territories, where herds wintered, when rivers froze solid enough to cross, which valleys offered shelter from killing winds. Knowledge accumulated over lifetimes had to be preserved and transmitted without writing. The solution was story. Myths of heroic ancestors who had faced similar challenges and survived. Tales that encoded practical information in memorable narratives. The hero who followed a specific star to find the secret valley where horses wintered. The maiden who learned from the snow spirits which ice was safe to walk upon. Around the fires in those bone houses, as storms raged outside that could kill in minutes. Humans did something remarkable. They didn't just endure, they flourished. They carved female figures from ivory, wove plant fibers into rope and textiles, and created lunar calendars from notched bones. They invented the bow and arrow, a technology that required understanding of wood grain, sinew properties, and projectile physics. They domesticated wolves into dogs, creating hunting partners and companions who would transform human capabilities forever. The last glacial maximum was humanity's graduation exam. Every skill the cognitive revolution had produced, planning, language, cooperation, innovation, symbolic culture, was tested to its absolute limit. And humans passed. When the ice finally began its retreat around 19,000 years ago, the survivors who emerged were masters of their world, carrying toolkits, both physical and mental, that could conquer any environment. They had looked into the white face of extinction and discovered they could imagine their way past it. Somewhere during those long winter nights, while watching the stars wheel overhead in patterns that never varied, a human mind made a crucial leap. The world was not chaos. It repeated itself. The same constellations rose with the spring rains. The moon fattened and shrank in reliable cycles. The herds migrated along invisible roads written in the seasons. Time itself had a structure, and that structure could be learned, mapped, and used. The evidence of this awakening appears in objects so subtle they were overlooked for decades. At Aubry-Blanchard in France, a 30,000-year-old carved bone bears a serpentine line of notches and holes that shifts in a pattern too deliberate to be decoration. When researcher Alexander Marshak examined it closely in the 1960s, he noticed something extraordinary. The notches changed in grouping and style in a way that matched the phases of the moon over 2.5 months. This was not art. It was notation, humanity's first written record, tracking time itself. Similar carved bones appear across Ice Age Europe. Some show tally marks in groups of 28, the lunar month. Others display more complex patterns that may track multiple celestial cycles simultaneously. The moon's phases, the movements of Venus, or the seasonal positions of key constellations. These are cognitive tools, external memory devices that free the mind from having to hold every observation internally. By making marks on bone or stone, humans could accumulate observations across years, comparing this spring to the last, this migration to those remembered by the elders. Why did this matter? Because prediction is power. A group that knew the rains would come in 3 moons could plan their movement to arrive at the best fishing grounds precisely when the runs began. Hunters who could predict when caribou herds crossed certain valleys could position themselves days in advance. Gatherers who tracked the flowering cycles of plants could return to harvest nuts or tubers at peak ripeness. Time was no longer something that happened to humans. It was something they could see coming and prepare for. This temporal awareness required a radical expansion of mental capacity. Most animals live in an eternal present, responding to hunger, fear, or desire as they arise. Even planning, a squirrel burying nuts, is largely instinctive. But to track the moon's cycle and connect it to seasonal rains requires holding multiple timescales in mind simultaneously. Yesterday's observation, last month's pattern, last year's floods, and next month's prediction. The mind must be able to project itself forward and backward, to stand outside the present moment and see it as one bead on a string stretching in both directions. At megalithic sites that would later dot the European landscape, stone circles and alignments whose construction wouldn't begin for thousands of years. We see this temporal thinking taken to its architectural conclusion. Places like Göbekli Tepe in Turkey, built 11,600 years ago by people who were still hunter-gatherers, show massive stone pillars arranged in circles aligned to celestial events. These weren't shelters or practical structures. They were observatories and ritual spaces where communities gathered to mark the turning points of the year. The painted caves, too, may have served as calendars of a kind. Some researchers suggest that certain chambers were visited at specific times of year, that the placement of animals on walls corresponded to their seasonal migrations, that the experience of moving through the cave was a journey through time itself. From spring hunts deep in the earth's womb to winter ceremonies in the outer chambers. This awakening of calendar consciousness did more than improve survival. It changed the structure of human thought itself. The past became a place you could visit through memory and story. The future became a destination you could imagine and plan for. History, the sense that today is connected to yesterday and will lead to tomorrow, became possible. Humans were no longer trapped in the immediate moment like every other creature. They lived simultaneously in past, present, and future. And that temporal freedom would soon allow them to do something no wild animal could conceive of, to deliberately reshape the world itself. With time now mapped and the future imaginable, humans began to do something that would have been unthinkable to earlier minds. They started tinkering with the world, not just taking from it, but actively shaping it to produce more of what they wanted. Long before anyone planted the first deliberate field, humans were gardening the wilderness itself, conducting experiments that would span generations and eventually transform our species from wanderers into settlers. The evidence for this proto-agriculture is subtle, easily missed, because it leaves no grand monuments. But it's there in the pollen records, in the distributions of plants that make no sense without human intervention, in the gradually changing sizes of seeds found in ancient camps. Around 23,000 years ago at Ohalo Tseku in Israel, we find grinding stones worn smooth from processing wild grains, and the remains of over 140 plant species being systematically harvested. These people weren't farmers, but they were already managing plant resources with sophisticated understanding. In Australia, Aboriginal peoples developed what anthropologists now call fire stick farming, the deliberate burning of undergrowth at specific times of year to clear pathways, encourage new grass growth that attracted game, and favor certain plant species over others. To outsiders, it looked like wilderness, but it was actually a carefully managed landscape, shaped by human hands over thousands of years. The knowledge of when to burn, where to burn, and what plants would respond was encoded in dreamtime stories that served as agricultural manuals wrapped in myth. In the oak forests of Europe and the nut groves of the Middle East, humans began selective harvesting, taking only from certain trees, leaving others, in patterns that, over generations, favored trees with larger nuts, thinner shells, or more predictable yields. They didn't understand genetics, but they understood observation. The tree that produced the sweetest acorns was protected, its territory kept clear of competitors, its nuts preferentially scattered in favorable spots. Over centuries, this unconscious selection began to change the forests themselves. The mental shift this required was profound. For millions of years, the environment was a given, a stage on which life played out, but which could not itself be altered. You could learn its patterns, exploit its offerings, but not change its fundamental nature. Now humans began to see the landscape as a system they could manipulate. If burning this field in the dry season produced better tubers next year, then burning became a tool. If protecting this stand of fruit trees from browsers resulted in more fruit, then protection became a strategy. This required thinking in timescales beyond the immediate. A fire set today would show results only months later. A nut planted might not bear fruit for years. A decision to leave a particularly productive patch unharvested until the seeds scattered required imagining next year's abundance. The calendar minds that could track lunar cycles now turned that temporal awareness toward cause and effect, stretched across seasons. Stories and taboos became the mechanism for preserving this knowledge. The sacred grove that must not be entered during certain months was actually a seed bank being protected until dispersal season. The myth of the spirit, who punished those who overharvested, was a sustainable resource management strategy encoded as religion. The ritual burning that accompanied specific ceremonies was precision ecosystem management disguised as worship. These proto-farmers didn't see themselves as transforming the world. They were simply doing what had always been done, but with slightly more intention, slightly more planning, slightly more manipulation. Yet they were conducting the longest-running experiment in human history. They were learning to see themselves not as passengers in nature, but as gardeners of it. And some of them, in the fertile crescents and river valleys where wild grains grew thick, were about to take the experiment to its logical conclusion, to stop following the plants they ate and to make those plants follow them instead. The revolution that would create civilization was germinating in these small acts of manipulation, and nothing would ever be the same again. But before that revolution could fully unfold, the sky fell once more. Around 12,800 years ago, just as the ice sheets were finally retreating and the world was warming into a gentler age, something catastrophic happened. The geological record preserves a scar so dramatic that scientists are still arguing over what caused it and what it did to the humans who witnessed it. The evidence sits in a thin black layer of sediment found at hundreds of sites across North America, Europe, and Asia, dating to precisely this moment. Within this black mat layer, researchers have found a cocktail of materials that don't belong. Nanodiamonds that form only under extreme pressure and heat. Microscopic spherules of melted rock. Magnetic grains rich in iridium and platinum. Elements rare on Earth's surface, but common in asteroids and comets. And vast quantities of charcoal suggesting continent-scale wildfires. Above this layer, the bones of Ice Age megafauna, mammoths, mastodons, giant ground sloths, saber-toothed cats, vanish abruptly. Below it, they're abundant. The line is sharp as a knife cut through time. The hypothesis is stark. Earth passed through a debris stream from a fragmenting comet. Instead of one impact crater, the planet was hit by thousands of airbursts and strikes across the northern hemisphere. The explosions ignited forests from California to Europe. Smoke and ash choked the sky. The heat flash-melted portions of the North American ice sheet, unleashing floods that make modern tsunamis look like puddle splashes. Massive volumes of fresh water dumped into the North Atlantic disrupted ocean currents, and the warming climate that had been underway suddenly reversed. Within decades, perhaps within years, temperatures plunged back toward Ice Age conditions. This cold snap, called the Younger Dryas, lasted for more than 1,000 years. Whether the cause was cosmic impact, volcanic eruption, or some combination of factors, the effect on human populations was devastating. In North America, the Clovis culture, the first widespread tool tradition, disappears from the archaeological record at exactly this boundary. Settlements are abandoned. Population crashes. On other continents, the story repeats with local variations. Climate whiplash, ecological collapse, mass extinctions, and human societies forced to adapt or die. For our story, what matters is not settling the scientific debate over cause, but recognizing the pattern. This was not the first cataclysm our ancestors endured, nor would it be the last. The Toba eruption 74,000 years ago, the wild climate oscillations of the glacial cycles, the Younger Dryas, repeated droughts, floods, and sudden temperature swings that could transform grasslands into deserts or turn forests into tundra within a human lifetime. Our species came of age in a world that was fundamentally unstable. This may be the secret hiding in plain sight. While other human species evolved for stability, Neanderthals perfected for 300,000 years of European cold. Denisovans adapted to high-altitude constancy. We evolved for chaos. Our brains are not optimized for a single environment, but for rapid switching between strategies. Our culture is not rigid tradition, but flexible innovation. Our social structures can reorganize from nomadic bands to settled villages to hierarchical chiefdoms within a few generations. Catastrophe, rather than destroying us, may have been the forge that hammered our cognitive flexibility to its sharpest edge. A stable world rewards specialization and conservative adherence to what works. A chaotic world rewards the ability to imagine entirely new solutions, to simulate scenarios that have never existed, to psychologically endure the trauma of watching everything familiar destroyed, and still find the will to rebuild differently. The humans who survived the Younger Dryas carried not just genes but memories, encoded in myths of world-ending floods, of fire from the sky, of ages when giants walked the earth and then vanished. These stories were not entertainment. They were warnings and instruction manuals passed down through generations. The world can end, has ended, and will end again. Those who survive are those who can adapt, who can imagine new ways of living when the old ways become impossible. And in the aftermath of this latest catastrophe, as the climate finally stabilized into the warm period we still inhabit, those survivors would put that adaptive capacity to use in ways that would change the world forever. In the aftermath of these repeated catastrophes, survival depended on a resource more precious than any tool or territory: memory. But in a world without writing, memory could not be stored on clay tablets or pressed into books. It lived only in human minds, fragile and mortal, always one generation away from total erasure. The solution our ancestors developed was as elegant as it was powerful. They turned survival information into stories so compelling that forgetting them became almost impossible. The elders were the living libraries, A grandmother who had lived through 70 winters carried in her mind a map of the territory more detailed than any modern GPS. Every water source, every sheltered valley, every patch of medicinal plants, every game trail, and crucially, the knowledge of what to do when the usual sources failed. She remembered the drought 30 years ago, and where the hidden spring continued to flow when all the rivers dried to dust. She knew which roots could be eaten in desperation and which would kill, which mushrooms healed wounds and which brought visions, which stars to follow when crossing the desert, and which landmarks warned of sinkholes that could swallow a hunter. But individual memory, no matter how vast, dies with the individual. The critical innovation was encoding this knowledge in forms that could be transmitted, that would lodge so deeply in listeners' minds they could not be forgotten. This is where myth becomes technology. A story about a hero who traveled up a specific river, crossed a mountain range by following a particular constellation, and found a valley where strange fruit grew. This wasn't fantasy. It was a navigation manual and resource map compressed into narrative. The hero might be a composite of many travelers. The strange fruit might be a crucial food source available only at certain elevations. The quirky monsters guarding dangerous places were warnings about real hazards: thin ice, poisonous plants, territorial predators, or hostile neighboring groups. Australian Aboriginal songlines are perhaps the most sophisticated example of this technology still practiced today. These are songs that describe the landscape in such precise detail that they function as verbal maps, allowing people to navigate hundreds of kilometers across desert by following the features described in the song. Each verse corresponds to a landmark. The rhythm matches the walking pace. Sacred stories and practical geography are woven so tightly together that you cannot separate them. To forget the song is to forget the way home. So the song is taught with ritual intensity, performed and re-performed until it becomes part of the listener's identity. The emotional charge of these stories was not decoration. It was a memory enhancement mechanism. The human brain is wired to remember emotionally significant events far better than neutral information. You might forget 1,000 mundane days, but the day you were chased by a lion is seared into memory with perfect clarity. Storytellers exploited this, loading survival information into narratives filled with danger, desire, betrayal, and triumph. The medicinal plant wasn't just identified by its leaves, it was the herb that the trickster god stole from the underworld to save his dying child. Now you'll never forget it. Rhythm, repetition, and ritual further reinforced the encoding. Information chanted in ceremonial contexts, repeated at seasonal gatherings, performed with music and dance, became neurologically embedded through multiple sensory pathways. The annual retelling of the creation story wasn't religious indoctrination. It was a data backup protocol, ensuring that critical cultural information was refreshed in every generation's memory. This system worked astonishingly well. Oral traditions have been shown to preserve accurate information across timescales that stagger the imagination. Aboriginal Australian stories describe landscapes and events from when sea levels were lower, events that geology confirms happened more than 10,000 years ago. Coastal flood myths from cultures around the world may preserve memories of the rapid sea level rise at the end of the Ice Age. These are not vague legends, but specific, detailed accounts that have survived hundreds of generations through nothing but human memory and the power of a well-told story. The human mind that emerged from the cognitive revolution wasn't just intelligent. It was a finely tuned narrative engine, optimized for packaging the world into memorable stories and transmitting them across time. We don't just think in language. We think in plots, characters, and dramatic arcs, because that's how our ancestors survived when the library was flesh and the archive was mortal. As the world finally warmed and stabilized around 11,700 years ago, entering the geological epoch we call the Holocene, some human groups made a decision that would have seemed insane to their ancestors. They stopped moving. For millions of years, human survival meant mobility, following herds, tracking seasonal resources, spreading risk across vast territories. Now, in certain blessed locations where resources were dense and reliable, people began to experiment with something unprecedented: permanent settlement. The Natufian culture of the Levant was among the first to cross this threshold. Around 12,500 years ago, in the arc of land stretching from the Jordan Valley to the Mediterranean coast, they built villages of circular stone houses, some holding up to several dozen people year-round. These weren't temporary camps, but engineered settlements with plastered floors, storage pits carved into bedrock, and cemeteries that accumulated generations of dead in one location. The people still hunted gazelle and gathered wild grains, but they returned to the same place each night, watched the same horizon, and began to see the land not as a resource to visit, but as territory to defend. The transformation this created was total and irreversible. Mobile hunter-gatherers can walk away from their garbage, their parasites, and their conflicts. Settled villagers cannot. Waste accumulates. Flies, rats, and disease-carrying vermin move in as permanent neighbors. Contagious illnesses that would have burned out in mobile bands now spread efficiently through densely packed households. Skeletons from early agricultural villages show dramatic increases in dental disease, malnutrition, and infectious disease markers compared to their mobile ancestors. Settlement, it turns out, was initially terrible for human health. The social strains were equally severe. The human mind evolved in bands of 25 to 50 individuals who spent most of their time outdoors, often dispersed across the landscape, regrouping at campsites in the evening. Privacy was abundant. Space was infinite. If tensions rose, groups could fission, the dissatisfied simply walking away to join relatives elsewhere. Now, in villages of 100 or more people packed into permanent structures, escape was no longer an option. You couldn't avoid the neighbor whose habits irritated you, the relative you'd quarreled with, or the family competing for the same resources. New psychological technologies had to be invented to make this arrangement survivable. Property became a necessary concept. When you return to the same house year after year, when you've invested labor in clearing land or building storage, that location becomes yours in a way that a temporary campsite never could. But property creates disputes over boundaries, over inheritance, over theft. Villages needed conflict resolution mechanisms more sophisticated than a leader's charisma or the threat of splitting the group. Evidence appears of formalized authority. At sites like Göbekli Tepe and later Çatalhöyük, we see communal buildings far larger than any dwelling, requiring coordinated labor from dozens of people. Someone had to organize that labor, settle disputes, and allocate tasks. The egalitarianism of mobile bands began to crack under the weight of permanent settlement. Some individuals accumulated more status, more influence, more control over stored resources. Hierarchies emerged, not because humans suddenly became greedy or power-hungry, but because permanent settlement created organizational problems that flat social structures couldn't solve. Who controls the communal grain storage? Who decides when to plant and when to harvest? Who mediates when two families claim the same plot? These questions had never existed before, and answering them required concentrating decision-making power in ways that would have been unthinkable and unnecessary for mobile foragers. The village was a crucible that forced rapid cultural evolution. Norms around cleanliness, noise, children's behavior, and sacred versus profane spaces had to be negotiated and enforced. Rituals intensified, creating shared identity and reducing conflict through synchronized emotion and purpose. Religious specialists, shamans, priests, may have gained new importance as mediators between the human and spirit worlds, but also as psychological managers of communities under stress. The people living through this transformation couldn't have known they were conducting an experiment that would reshape humanity. They likely experienced it as a series of practical choices. This valley has reliable water, these grains are abundant. Why not stay another season? But with each season that became a year, each year that became a generation, the trap closed tighter. Storage and investment locked them in place. The village experiment, once begun, proved almost impossible to reverse. And it was about to accelerate into something even more radical. Once locked in place, the next step became almost inevitable. Why simply gather the wild grains that grew nearby when you could clear the competing plants, scatter more seeds, and increase the yield? Why follow wild goats across mountains when you could pen the young ones, feed them, and keep them close? Around 10,000 years ago in the Fertile Crescent, and independently in China, Mesoamerica, and other regions, humans crossed a threshold from which there would be no return. They stopped being participants in nature and became its managers. They invented agriculture. The transition left marks in the seeds themselves. Wild wheat and barley have brittle stalks that shatter when ripe, scattering seeds across the ground, perfect for reproduction, terrible for human harvesters who lose most of the grain before they can gather it. But a few mutant plants had a recessive gene that made their stalks tougher, keeping seeds attached. In nature, this was a disadvantage. In human hands, it became destiny. Harvesters preferentially gathered these non-shattering heads, brought them back to settlements, and planted them the next season. Within a few thousand years, domesticated grain was genetically distinct from its wild ancestors, entirely dependent on human hands for planting, unable to reproduce without us. We had created plants that could not survive without human intervention, and in doing so, we had bound ourselves to them just as tightly. Animals underwent the same transformation. Wild goats are skittish, aggressive, and nearly impossible to control. But humans kept the calmest individuals, the ones least likely to bolt or attack. And over generations, these traits became fixed. Horns shrank, body size changed, behavior became docile. Sheep lost their color variation and grew woolly coats that required shearing. Cattle became manageable giants that would never have survived predation in the wild. Dogs had already made this journey thousands of years earlier, evolving from wolves into creatures so attuned to human social cues they could read our faces better than our primate cousins could. This wasn't partnership. It was a form of mutual captivity. The domesticated species became entirely dependent on humans for survival, their genetics sculpted to our needs. But we became just as trapped. Agriculture is far more labor-intensive than foraging. Wild food gathering required perhaps 20 hours of work per week. Farming demanded constant attention, clearing land, planting, weeding, watering, protecting from pests, harvesting, processing, storing. Farmers worked harder and longer than foragers, and skeletal evidence shows they were less healthy, suffering from nutritional deficiencies, repetitive stress injuries, and the diseases of crowding. Yet agriculture created something that changed everything: surplus. For the first time in human history, it became possible to produce more food than the immediate group needed. That surplus could be stored, controlled, and directed. This simple fact, the existence of stored calories that could be owned, transformed human psychology and social organization in ways that are still unfolding today. Surplus meant some people could specialize in activities other than food production. Craftsmen could spend days making pottery or tools, trading their goods for grain. Religious specialists could dedicate themselves to ritual, supported by the community's excess production. And critically, surplus meant power. Whoever controlled the grain stores controlled survival itself, especially during the lean months before harvest when stores ran low. New concepts crystallized that would have been alien to mobile foragers. Debt. I give you grain now, you owe me labor later. Inheritance. My son, not yours, will control these fields when I die. Divine favor. The gods blessed my harvest, but cursed yours. Proof of my righteousness. These ideas required abstract thinking about future obligations, bloodline rights, and invisible moral orders. The cognitive machinery that had evolved for tracking social relationships and coalition building now turned toward economics and theology. The rhythm of life itself transformed. Foragers lived in the eternal present, responding to opportunities as they arose. Farmers lived by the calendar, their entire year structured around planting and harvest seasons. They couldn't wander when bored or follow game when hunting was good. They waited, rooted to their fields like the crops they tended, watching the sky for rain, counting the days until harvest, and praying that disease, drought, or raiders wouldn't destroy the single resource on which their entire survival now depended. Freedom had been traded for stability, or at least the promise of it. The contract was signed in grain and blood, and there was no going back. The granaries changed everything, not just what people ate, but who they were. In the earliest farming villages, storage was communal, shared among all families. But as settlements grew and agriculture intensified, something new appeared in the archaeological record: differential storage. Some households had larger grain bins than others. Some families controlled storage buildings, while others had none. The moment food could be stockpiled, inequality became inevitable. At sites like Çatalhöyük in Turkey, occupied from 7500 BCE, the houses are remarkably uniform. No palaces, no obvious centers of power. People were buried beneath the floors of their homes with similar grave goods. But look closely at the distribution of storage containers, obsidian tools, and exotic trade goods, and patterns emerge. Some households had access to more resources, controlled better land, or possessed specialized knowledge that others lacked. The seeds of stratification were germinating even in these seemingly egalitarian villages. By the time we reach early Mesopotamian sites like Eridu and Uruk around 5000 BCE, inequality has blossomed into full-blown hierarchy. Temple complexes dominate settlements, their granaries bursting with collected tribute. Priest administrators live in larger houses with finer goods. Burials show dramatic disparities, some individuals interred with jewelry, weapons, and sacrificed attendants, while others are dumped in mass graves with nothing. The human mind, which had evolved exquisite sensitivity to social status as a survival mechanism in small bands, now found itself navigating hierarchies of dizzying complexity. This wasn't a corruption of human nature, but an expression of it under new conditions. In mobile foraging bands, status existed. Some individuals were more respected hunters, better storytellers, or wiser counselors. But status without the ability to accumulate and control resources remained largely symbolic. The best hunter might eat better for a day, but he couldn't store meat indefinitely or convert prestige into inheritable wealth. Mobility and sharing norms kept inequality in check. You can't accumulate what you can't carry, and you can't hoard what must be shared to maintain group cohesion. Agriculture shattered these constraints. Land itself became a resource that could be owned, defended, and passed to heirs. The family that controlled the most fertile plots or the best water access produced more surplus. That surplus could be invested in better tools, more livestock, or supporting more children who would work more land. Wealth began to compound across generations. For the first time in human history, being born into the right family mattered more than individual skill or effort. The social roles that emerged from this inequality required new cognitive categories. The chief or priest-king wasn't just a respected elder. He was a permanent authority whose decisions bound others, whose pronouncements carried the weight of divine sanction. The artisan who spent his days crafting pottery or smelting copper wasn't a hunter who occasionally made tools. He was a specialist whose entire identity was tied to his craft. Dependent on farmers for food, he no longer produced himself. These specialists made society more productive, but also more fragile. A village of generalists could survive if individuals died. Everyone knew how to hunt, gather, and make basic tools. But a society of specialists faced catastrophe if key individuals perished. The metallurgist's knowledge, the potter's technique, the priest's rituals, these had to be formally taught and preserved. Apprenticeship systems emerged, often hereditary, creating castes of knowledge keepers whose children inherited not just property, but profession. The human emotions that evolved to navigate small band politics, envy, ambition, shame, pride, now operated in an environment they had never been designed for. Envy in a foraging band might mean coveting a better spear or mate. In an agricultural society, it meant resenting the family whose granaries overflowed while your children went hungry. Ambition once meant seeking respect through skill or bravery. Now it meant accumulating resources, climbing social ladders, and ensuring your lineage's dominance over generations. Religion evolved to sanctify these inequalities. The chief's authority wasn't merely personal. He was chosen by the gods, his bloodline divinely ordained. The priest's control of ritual knowledge gave him power over the supernatural forces that determined harvest success or failure. To question the hierarchy became not just political rebellion, but cosmic transgression. The surplus stored in temple granaries wasn't theft. It was sacred offering. The laborers who built monumental architecture weren't exploited. They were earning divine favor. Yet the same cognitive revolution that enabled these systems of control also planted the seeds of resistance. The mind that could imagine invisible gods could also imagine justice, fairness, and alternative social arrangements. The capacity for empathy that allowed humans to cooperate could recognize suffering even in those outside one's immediate group. The tension between hierarchy and equality, between authority and autonomy, would become one of the defining contradictions of civilized life, and it remains unresolved to this day. The villages swelled, and then they exploded. By 3500 BCE, in southern Mesopotamia, a settlement called Uruk had grown into something the world had never seen, a true city. At its peak, Uruk housed perhaps 50,000 people within its massive walls, sprawling over 6 square kilometers of temples, workshops, markets, and densely packed residential quarters. This was more humans living in one place than had existed in entire regions just a few thousand years earlier. The cognitive revolution that had begun around Pleistocene fires now confronted its strangest environment yet: permanent crowds. Walking through Uruk's narrow streets would have been a sensory assault. The smell of human waste, animal dung, and cooking fires mixed with the acrid tang of pottery kilns and copper smelting. The noise was relentless. Merchants hawking goods, children playing, animals bleating, craftsmen hammering metal, priests chanting in temple courtyards. Privacy, which had been abundant in the open landscapes of our evolutionary past, became a luxury only the wealthy could afford behind thick walls and closed doors. For most urbanites, life meant constant proximity to strangers. This was psychologically unprecedented. The human brain evolved in environments where you knew everyone you regularly encountered, their names, their kin, their reputation, their history with you. Dunbar's number of 150 meaningful relationships had been more than adequate. But in Uruk, you might pass hundreds of unfamiliar faces in a single day. How do you navigate a social world where most people are strangers? How do you decide who to trust when you can't rely on kinship, shared history, or reputation networks? The answer was the invention of abstract social roles. Instead of knowing Enlil, my cousin's friend who is a skilled potter, you learned to interact with the potter, a categorical identity that carried expected behaviors regardless of the specific individual filling it. The merchant, the priest, the guard, the scribe. These became standardized roles that allowed strangers to cooperate without needing personal relationships. You didn't need to know the baker as an individual to trust that the bread he sold was made with standard measures and wasn't poisoned. The role itself carried the trust. This abstraction extended to institutions. In a village, you trusted the chief because you knew him personally. You'd watched him settle disputes, lead hunts, and care for the community. In a city, you couldn't personally know the king or the temple administrators, yet you had to trust that their decrees would be enforced, their measurements honest, their justice impartial. Trust shifted from individuals to systems. Laws, temples, weights, and measures, official seals that guaranteed authenticity. The cognitive load was enormous. Urban life required constantly switching between different social contexts and behavioral modes. In the marketplace, you haggled and calculated value. In the temple, you performed ritual submission. At home, you navigated family hierarchy. With your guild, you maintained professional reputation. Each context demanded different behaviors, different speech patterns, different facial expressions. The urban mind had to become a sophisticated social chameleon, code switching through multiple identities within a single day. Cities also became engines of innovation at a pace that would have been impossible in dispersed villages. When thousands of people with different skills lived in close proximity, ideas collided and recombined at accelerating rates. The potter who lived next to the metallurgist might discover that certain clays could withstand the heat needed for copper smelting, inventing crucibles. The merchant who traveled between cities brought back foreign techniques. The scribe who recorded grain transactions invented number systems that could track increasingly complex exchanges. Specialization meant that individuals could spend entire lifetimes perfecting single skills, achieving mastery impossible for generalists. But the same density that accelerated innovation also amplified stress. Our Pleistocene brains, wired for open landscapes and small groups, were now trapped in labyrinths of mud brick with no escape. The constant stimulation, the lack of privacy, the complexity of navigating thousands of relationships and roles, these pushed human psychology to its breaking point. Evidence from ancient cities shows rising rates of violence, disease, and social breakdown during periods of rapid urbanization. Yet humans adapted, as they always had. New cultural technologies emerged to manage urban stress, public festivals that created communal identity, neighborhood shrines that provided local belonging within the overwhelming city, professional guilds that offered smaller in-groups within the anonymous masses. Religion intensified, offering cosmic order and meaning in environments that could feel chaotic and alienating. The city, for all its psychological costs, had become the crucible where human potential, both creative and destructive, would be realized at scales unimaginable to our ancestors. The cognitive revolution had built the stage. Now the drama of civilization could truly begin. In the crowded administrative centers of Uruk, a crisis was brewing that memory alone could not solve. Temple granaries received tribute from hundreds of farmers. Workshops employed dozens of specialized craftsmen. Merchants traded goods across vast distances on credit that might not be repaid for months. The human mind, magnificent as it had become, could not track thousands of transactions, debts, and inventories simultaneously. The living library of elders and priests was reaching its limits. The solution, developed around 3200 BCE, would prove as transformative as language itself: writing. It began simply, almost accidentally. For centuries, Mesopotamian accountants had used small clay tokens to represent commodities: a cone for grain, a sphere for oil, a cylinder for animals. These tokens were enclosed in clay envelopes for security. But this created a problem. You couldn't see what was inside without breaking the seal. The solution was elegant. Before sealing the envelope, press the tokens into its wet surface, leaving impressions that recorded the contents. Then someone realized the tokens themselves were redundant. The impressions alone contained all the necessary information. From these practical accounting marks, writing exploded into existence with startling speed. Within a few centuries, the simple impressions evolved into a complex system of wedge-shaped signs, cuneiform, that could represent not just objects, but sounds, grammar, and abstract concepts. The earliest tablets are prosaic inventories: 29 jars of oil, 7 sheep, delivered by Kushim. But Kushim's name appearing on that 5,000-year-old receipt makes them perhaps the first identifiable individual in history. The first person whose name we know not from myth, but from their own written record. The implications were staggering. For the first time, information could be stored outside human memory with perfect fidelity across unlimited time. A contract written today remained unchanged tomorrow, next year, or a century later. No degradation from imperfect recall or deliberate revision. Legal disputes could be settled by consulting written records rather than conflicting memories. Agricultural knowledge accumulated in manuals that could be copied and distributed. Kings could issue laws that applied uniformly across territories too vast for oral transmission. Writing also changed the nature of time itself. Before writing, the past existed only in the fluid, malleable form of oral tradition. Stories that changed slightly with each retelling. Events that blurred together or vanished entirely when the last person who remembered them died. Writing froze moments in amber. The past became fixed, accessible, and increasingly distant from the present. History, as distinct from myth, became possible. Scribes in Babylon could read accounts of kings who ruled 1,000 years before them, creating an awareness of deep time that oral cultures could not sustain. The technology spread and diversified. In Egypt, hieroglyphs combined logographic and phonetic elements in ways distinct from cuneiform. In China, characters evolved independently from oracle bone divination. In Mesoamerica, the Maya developed sophisticated writing without influence from the Old World. Each system reflected the unique cognitive patterns of its creators, but all shared the fundamental breakthrough: thought made visible, memory made permanent. Yet writing also created new inequalities. In a world where knowledge was oral, anyone could potentially learn anything if they found a teacher willing to share. But writing required years of training to master. Scribal schools became gatekeepers of literacy, often restricting access to elite families or priestly castes. The scribe who could read and write held power over the illiterate masses, controlling access to laws, contracts, and sacred texts. Knowledge itself became a commodity that could be hoarded or sold. The first writings were mundane: receipts, inventories, tax records. But humans being human, it didn't take long before someone used this technology to record something else. On clay tablets in Mesopotamia, scribes began writing down the old stories: the flood, the hero kings, the creation of the world. The Epic of Gilgamesh, composed around 2100 BCE, represents writing's full maturation from accounting tool to literature. Here were emotions, philosophy, existential dread, and hope pressed into clay, the inner world made outer, the invisible made visible. This completed an arc that began 100,000 years earlier with scratched ochre in African caves. Humans had been externalizing thought in progressively sophisticated ways: first simple marks, then cave art, then pottery decoration, then tokens, and finally full writing systems. Each step took thought further outside the skull, making it more shareable, more durable, more capable of accumulating across generations. The cognitive revolution that gave us symbolic thinking had found its ultimate expression. Human consciousness, freed from the prison of individual mortality, now capable of speaking across millennia to minds not yet born. But we must pause here, step back from the triumphant march of civilization, and acknowledge the price paid for this cognitive revolution. The same mind that could imagine cities and record history could also imagine its own annihilation. The same consciousness that allowed us to plan for tomorrow forced us to confront the fact that our tomorrows were numbered. We had become the only animal cursed with the knowledge of its own mortality. The evidence of this existential wound appears everywhere once you know to look for it. In graves across the ancient world, bodies are buried with goods clearly meant for an afterlife: food, tools, weapons, jewelry. At Sungir in Russia, 34,000 years ago, a child was interred with over 5,000 laboriously carved ivory beads, fox teeth, and ivory spears. This wasn't decoration of a corpse, it was provision for a journey. The effort invested suggests desperate hope, or perhaps desperate fear, that death was not truly the end. Amulets and talismans proliferate as cities grow. Carved eyes to ward off evil gazes, cylinder seals inscribed with protective prayers. Figurines of deities tucked into house foundations to guard against invisible threats. These objects reveal minds perpetually anxious, scanning for dangers both real and imagined. The cognitive machinery that evolved to detect predators and rivals now generated phantom threats: curses, demons, the evil eye, divine displeasure. The world became haunted, not because it had changed, but because our perception of it had. The self-awareness that made us successful also made us neurotic. A chimpanzee lives in the present. It can be frightened by immediate danger and will remember past traumas, but it doesn't lie awake contemplating its inevitable death or worrying about social mistakes made years ago. The human mind, with its capacity for mental time travel and recursive thought, became trapped in loops of anxiety. We could imagine every possible future catastrophe and replay every past humiliation with perfect emotional vividness. The same simulation engine that let us plan complex hunts now tortured us with scenarios of rejection, failure, and death. Religions evolved partly as cognitive technologies for managing this terror. The Mesopotamian temples, the Egyptian pyramids, the elaborate burial customs found across cultures. These weren't just about appeasing gods, but about asserting control over the uncontrollable. If you performed the right rituals, made the right offerings, lived according to divine law, perhaps you could negotiate with death itself. The afterlife became a story we told ourselves to make mortality bearable. And the more elaborate the story, the more psychological comfort it provided. Philosophy emerged from the same wound. The earliest written texts we have aren't just pragmatic records, but existential grappling. The Epic of Gilgamesh is fundamentally about a king's terrified confrontation with mortality and his futile quest for immortality. Egyptian wisdom literature contemplates the meaning of a good life in the face of inevitable death. These ancient thinkers were using the very consciousness that tormented them to try to find peace with their condition. Art, too, served this function. The cave paintings weren't just hunting magic. They were attempts to capture and freeze the transient, to make the fleeting permanent. The sculptures, the poetry, the music that appears in every culture are all ways of reaching beyond the self's boundaries, of creating something that will outlast the fragile body. Art is humanity's rebellion against mortality, our insistence that something of us can persist even as our flesh returns to dust. But no amount of art, ritual, or philosophy could fully quiet the anxiety hardwired into our expanded consciousness. The archaeological record shows evidence of what we would now recognize as mental illness appearing alongside civilization. Depression, anxiety disorders, psychosis. Texts describe conditions that sound remarkably like PTSD, panic attacks, and obsessive behaviors. The mind that could imagine infinite possibilities was also vulnerable to being overwhelmed by them. This is the dark side of the cognitive revolution that is rarely discussed in triumphalist narratives. Yes, we built cities and wrote epics and domesticated the world. But we also became the most anxious, the most existentially terrified, the most psychologically fragile species on Earth. We gained the ability to reshape our environment, but lost the animal's gift of simply being present. We won the evolutionary lottery and inherited a prize that sometimes feels like a curse. A consciousness aware of its own impermanence. Powerful enough to change the world, but powerless to stop its own inevitable end. The revolution that made us human also made us uniquely capable of suffering. And that suffering, inscribed in ancient prayers and grave goods and temple offerings, echoes across the millennia into our own restless minds. Yet even as ancient anxieties haunt us, modern science has developed tools that would seem like magic to our ancestors. The ability to read the dead's most intimate secrets from fragments of bone no larger than a grain of rice. In the last 2 decades, ancient DNA analysis has revolutionized our understanding of human origins, revealing a story far stranger and more complex than anyone imagined. The ghosts that haunted our ancestors' dreams turn out to be written into our very cells. The breakthrough came in 2010 when scientists successfully sequenced the Neanderthal genome from 40,000-year-old bones found in Siberian caves. The analysis revealed something shocking. Modern humans outside Africa carry between 1% and 4% Neanderthal DNA. This wasn't contamination or error. It was the genetic signature of ancient interbreeding. Our ancestors hadn't simply replaced Neanderthals through competition. They had merged with them, absorbed them, carried pieces of them forward into the future. Every non-African human alive today is part Neanderthal. The Denisovan revelation was even more startling. From a single finger bone and a few teeth found in Denisova Cave, scientists extracted DNA from a previously unknown human species. These weren't just genetic curiosities. Denisovan genes persist in living populations, particularly in Tibet, Papua New Guinea, and Australia. The EPS1 gene variant found in Tibetans, which allows them to thrive at high altitudes where others struggle, came directly from Denisovan ancestors who had already adapted to mountain life tens of thousands of years earlier. We literally borrowed evolutionary solutions from species we helped drive to extinction. But the ghosts go deeper still. African genomes reveal traces of archaic humans that have left no fossil remains we can identify. Populations that diverged from our lineage hundreds of thousands of years ago, interbred with our ancestors, and then vanished completely except for these molecular echoes. We are haunted by people we cannot name, whose faces we will never see but whose genes we still carry. Ancient DNA also lets us watch evolution in action across historical time. When humans adopted agriculture, genes related to starch digestion underwent rapid selection. The AMY1 gene, which produces the enzyme that breaks down starch, increased in copy number in agricultural populations, but remained low in groups that continued foraging. We can see this happening within a few thousand years. Evolutionary time-lapse photography showing our genomes adapting to the new diets we created. Disease resistance tells even more dramatic stories. After the Black Death ravaged Europe in the 14th century, certain immune system variants increased dramatically in frequency. The people who survived carried genetic advantages against plague, and those advantages spread through the population. Ancient DNA from before and after plague episodes lets us track these selective sweeps with precision impossible in living populations alone. The genetic record complicates the neat narrative of a sudden cognitive revolution 50,000 years ago. Instead, we see a mosaic of changes accumulating across hundreds of thousands of years in different populations. Some groups developed certain cognitive or physiological advantages earlier than others. When these groups met and interbred, their genetic innovations were pooled, creating new combinations that might have crossed critical thresholds. For instance, some of the Neanderthal DNA we carry affects brain development and function. Variants that influence skull shape, neural connectivity, and even sleep patterns came from our archaic cousins. We didn't just develop modern cognition in isolation and then spread it. We absorbed useful variants from every human species we encountered, creating a hybrid genome that drew on hundreds of thousands of years of parallel evolution across multiple lineages. The molecular record also reveals selection pressures we're only beginning to understand. Genes affecting skin pigmentation, hair texture, eye color, and other visible traits underwent strong selection as humans spread into new latitudes and climates. But equally strong selection occurred in genes we can't see. Immune function, metabolism, even behavior and cognition. The human genome has been a work in progress throughout our history, constantly being edited by the environments and cultures we created. Perhaps most humbling, the DNA shows us that the story isn't over. Selection continues today, though it operates on different traits. Disease resistance in urban environments, lactose tolerance in dairy-consuming cultures, altitude adaptation in mountain populations. We are still evolving, still being shaped by the world we have made. The ghosts in our genes are not just relics of the past, but active participants in our present, and their influence will echo into whatever future awaits our strange, hybrid species. While ancient DNA reveals what changed in our genes, modern neuroscience is mapping what those changes built. The 3-pound universe inside our skulls that makes us human. Using technologies that would have seemed like sorcery to our ancestors, scientists can now watch thoughts forming in real time, track neural circuits as they process language, witness the brain constructing the very sense of self that contemplates its own existence. What they've discovered is both humbling and profound. We are still running on hardware designed for the Pleistocene, pushed far beyond its original specifications. Functional MRI scanners reveal the geography of thought by tracking blood flow to active brain regions. When subjects lie in the machine and listen to stories, entire networks light up in coordinated symphonies of activity. Language processing engages not just classic speech areas like Broca's and Wernicke's regions, but vast networks spanning both hemispheres. Metaphor comprehension activates sensory and motor areas. When you hear, "She grasped the idea," your brain briefly simulates the physical act of grasping. Language, it turns out, is deeply embodied, rooted in the same circuits that evolved to coordinate movement and perceive the world. The default mode network, discovered almost accidentally when researchers noticed consistent activity during rest periods, may be the neural signature of what makes us uniquely human. This network, spanning the medial prefrontal cortex, posterior cingulate, and temporal lobes, activates when we're not focused on external tasks. When we daydream, remember the past, imagine the future, or think about what others might be thinking. It's the brain's narrative engine, constantly constructing stories about ourselves and others, running simulations of social scenarios, engaging in the mental time travel that our ancestors used to plan hunts and navigate social hierarchies. Remarkably, this same network shows reduced activity in other primates and is underdeveloped in young children, only reaching full maturity in adolescence. The default mode network may be the neural infrastructure that supports the recursive, imaginative thinking that exploded 50,000 years ago. Its expansion and elaboration in modern humans could be one of the key architectural changes that enabled symbolic culture, long-term planning, and the rich inner life that characterizes our species. The prefrontal cortex, massively expanded in humans compared to other apes, houses the circuitry for executive function, impulse control, planning, abstract reasoning, and delayed gratification. Classic experiments show humans can resist immediate rewards for larger future payoffs in ways other animals struggle to manage. This capacity underlies everything from agriculture, plant now, eat later, to civilization itself, sacrifice personal freedom for collective security. Yet these circuits are metabolically expensive and develop slowly, which explains why children struggle with self-control and why stress or fatigue can temporarily reduce us to more impulsive states. Social cognition networks show particularly interesting patterns. The temporoparietal junction and medial prefrontal cortex activate strongly during theory of mind tasks. When we think about what others are thinking, single-cell recordings in surgical patients have even found individual neurons that respond specifically to social information. One study identified cells that fired when subjects viewed particular individuals, a Jennifer Aniston neuron that responded to photos, drawings, or even the name of the actress. We literally have neural real estate dedicated to tracking other people. Perhaps most tellingly, ancient reward pathways, the dopamine systems that evolved to make animals seek food, sex, and safety, respond just as strongly to social rewards in humans. Brain scans show that receiving compliments, gaining status, or learning that others admire us activates the same neural circuits as cocaine or chocolate. This explains why social media is so addictive and why our Pleistocene brains treat status threats as seriously as physical danger. The same reward circuits that kept our ancestors motivated to hunt and gather now drive us to accumulate likes, followers, and social validation. These scanning technologies hint at what might have changed in deep time to trigger our cognitive revolution. Small alterations in the connectivity between brain regions, in the density of particular neurotransmitter receptors, or in the timing of developmental processes could have massively amplified existing capabilities. The difference between a human brain and a Neanderthal brain might not be in entirely new structures, but in subtle recalibrations. A default mode network slightly more active, prefrontal circuits slightly more connected, social reasoning areas slightly more developed. evolution tinkers at the margins, and sometimes tiny adjustments to complex systems produce transformative results. The brain scans reveal the hardware, but they miss the most important development of all. Once the cognitive revolution ignited, culture itself became a second evolutionary force, one that operates at speeds that make genetic evolution look frozen in place. While our DNA has changed only marginally in the last 50,000 years, our cultures have transformed beyond recognition thousands of times over. We have become a species whose primary adaptation is the ability to adapt culturally, and that capacity has entered a phase of exponential acceleration. Consider the transmission of stone tool making. A Homo erectus hand axe from 1.5 million years ago looks nearly identical to one made 500,000 years later, a million years of technological stasis. Even early Homo sapiens showed relatively slow tool innovation for their first 200,000 years. But after the cognitive threshold was crossed, tool technologies began evolving within human lifetimes. The progression from simple blades to microliths, to composite tools, to bows, to specialized fishing gear occurred across just 30,000 years. Blindingly fast by evolutionary standards. Each innovation built on the last, creating cumulative technological culture that ratcheted ever upward. This is fundamentally different from genetic evolution. DNA changes through random mutation and natural selection, a slow process requiring differential reproduction across generations. But cultural information, techniques, beliefs, stories, technologies, can spread horizontally between unrelated individuals and can be improved intentionally through innovation and problem solving. A useful idea can sweep through a population in years rather than millennia. And crucially, cultural evolution is Lamarckian. Acquired characteristics can be inherited. The skills you learn in your lifetime can be taught to your children directly, not encoded slowly into genes. Anthropologists have identified the mechanisms of cultural evolution, which eerily parallel biological evolution. Cultural variants, different ways of making tools, organizing societies, or explaining the world, compete for adoption. Those that prove useful, memorable, or emotionally compelling spread and persist. Those that fail disappear, sometimes taking their adherents with them. Cultural mutation occurs through innovation, error, and creative recombination. Cultural selection happens through differential adoption. Some ideas catch on while others fade. But cultural evolution has unique features that biological evolution lacks. Ideas can merge and recombine in ways genes cannot. Agriculture plus metallurgy plus writing equals civilization. In a synthesis no biological organism could achieve. Cultural evolution can also accelerate deliberately. We don't wait for random mutations to solve problems. We consciously invent solutions, test them, and refine them. This intentionality makes cultural evolution potentially millions of times faster than genetic evolution. The consequences are staggering. Fire-making took hundreds of thousands of years to perfect and spread. Agriculture emerged independently in multiple locations over about 10,000 years. Writing appeared in perhaps 5,000 years. The printing press spread across Europe in decades. The internet achieved global penetration in years. We are watching cultural evolution accelerate before our eyes, each new communication technology further increasing the speed at which ideas can spread and recombine. This creates a bizarre situation. We are Stone Age brains navigating a world that changes faster than we can biologically adapt to it. The neural machinery that evolved for tracking 100 social relationships now manages thousands of online connections. Reward systems designed to motivate foraging now drive consumption in environments of artificial abundance. Fear circuits calibrated for predators now trigger anxiety about abstract threats like economic collapse or climate change. We are, neurologically, fish out of water, Pleistocene minds in digital environments. Yet this mismatch is precisely what drove our success. A species whose adaptation is hardwired into genes is locked into its niche. A species whose adaptation is cultural can reinvent itself with each generation. When climate changed, other species waited for natural selection to reshape their bodies. We reshaped our cultures, new tools, new strategies, new social organizations, and survived. The same process continues today at dizzying speed. Technologies, ideologies, economic systems, and social norms compete for dominance in a global marketplace of ideas. Successful variants spread virally. Failed experiments collapse. We are conducting evolution in real time. Not on biological populations, but on the ideas and institutions that structure civilization itself. The techniques once used to refine stone blades are now refining algorithms, ideologies, and global systems. But there's a critical difference. Biological evolution has no foresight and no values. It simply favors whatever reproduces. Cultural evolution can be guided by human intention and values, but it can also be hijacked by ideas that spread effectively but harm their carriers. Conspiracy theories, addictive technologies, and destructive ideologies can propagate virally precisely because they exploit our cognitive biases, not because they benefit us. The same mental machinery that allowed us to survive the Pleistocene now makes us vulnerable to mimetic viruses our ancestors never faced. The acceleration continues, and somewhere in the blur between cultural evolution and catastrophe, we crossed another threshold, one whose consequences we are only beginning to comprehend. The same cognitive revolution that allowed a small African ape to survive ice ages and colonize the planet has transformed us into a geological force powerful enough to alter Earth's climate, chemistry, and biology. We have become the asteroid, the volcano, the ice age, a single species reshaping the entire planetary system. Geologists now debate whether to name a new epoch after us, the Anthropocene, the age of humans. The evidence is written in stone, ice, and atmosphere. Future geologists will find a distinct layer in Earth's sediments marking our presence. Plastics that will persist for millions of years. Radioactive isotopes from nuclear tests scattered globally. Concrete and asphalt covering vast swathes of continents, and fossils showing a mass extinction event comparable to the one that killed the dinosaurs. Except this time, the cause isn't a space rock, but a species that learned to think symbolically and plan for the future. The same planning circuits that allowed our ancestors to predict seasonal migrations now build dams that reroute entire river systems. The Aswan Dam on the Nile, the Three Gorges on the Yangtze. These are engineering feats that dwarf the pyramids, redirecting water flows that have shaped continents for millions of years. We have altered more than half of Earth's ice-free land surface, turned forests into farms, prairies into parking lots, and rivers into managed channels. From space, the planet at night glows with our cities, a web of light announcing our dominance. The symbolic thinking that created shell beads and cave art has evolved into economic systems of staggering abstraction. Money, corporations, stock markets, derivatives. These are fictions our collective imagination has conjured into reality. And they now drive physical transformations of ecosystems on continental scales. The Amazon rainforest falls to produce soybeans traded on Chicago futures exchanges. Indonesian peatlands burn to grow palm oil for global supply chains. Entire landscapes are reshaped not by local needs, but by abstract market forces operating through digital networks our ancestors could never have conceived. Our tribal psychology, which evolved to navigate bands of 150 people, now operates on a global stage with apocalyptic weapons. The same in-group, out-group thinking that helped our ancestors cooperate and compete with neighboring bands now divides billions into religious, national, and ideological camps. But where once tribal conflicts were fought with spears and affected hundreds, our conflicts now deploy nuclear weapons capable of extinguishing civilization itself. We have armed our Pleistocene tribal instincts with technology powerful enough to render the planet uninhabitable. Perhaps most ironically, the imagination that saved us from Pleistocene winters is now warming the entire planet. Our ability to plan ahead and manipulate our environment led us to fossil fuels. Ancient sunlight stored in coal, oil, and gas, which were burning at rates that release carbon accumulated over hundreds of millions of years within mere centuries. The greenhouse effect we've triggered is raising global temperatures faster than at any point in human history. Ice sheets are collapsing, sea levels rising, weather patterns destabilizing. We are conducting an uncontrolled experiment on the only atmosphere we have, driven by the same cognitive tools that once kept us warm in mammoth bone huts. The capacity for abstract thought that created writing and mathematics now edits the genetic code itself. CRISPR and gene editing technologies allow us to rewrite DNA with precision our ancestors could never have imagined when they first selected seeds for favorable traits. We are engineering organisms that have never existed, inserting genes across species barriers, and contemplating modifications to our own germline that would affect all future generations. The tinkering that began with proto-agriculture has reached into the molecular machinery of life itself. We have become victims of our own success, our capabilities having outrun our wisdom. Every adaptation that made us successful, planning, abstraction, social coordination, innovation, now operates at scales and speeds that strain our ability to manage the consequences. We are running Pleistocene software on a civilization-scale operating system, and the bugs in the code are becoming existential threats. The cognitive revolution that began with a few humans scratching patterns on ochre has culminated in a species capable of both breathtaking creation and catastrophic destruction. We stand at an inflection point where the same minds that painted Chauvet's magnificent horses must now decide whether to paint ourselves into extinction or imagine and implement a way forward that our planetary impact doesn't doom us and countless other species sharing this fragile world. We return now to where we began, to that small band huddled around a dying fire 70,000 years ago, watching strange lights burn across the heavens, feeling the ground tremble beneath them. By morning, their world was ash and ruin. Yet something awakened in the survivors, something that had been building for millennia in scattered populations across Africa, waiting for the right moment, the right crisis, the right convergence of genes and culture to ignite fully. What exactly changed in those crucial millennia between 70,000 and 50,000 years ago? The honest answer is, we still don't know completely. It wasn't a single mutation, a solitary genius, or a bolt of divine inspiration. It was more likely a cascade. Genetic changes accumulating across populations, cultural innovations reaching critical mass, catastrophes pruning away less adaptable lineages, and survivors carrying forward a unique combination of traits that crossed some invisible threshold into full behavioral modernity. Perhaps it was regulatory tweaks to genes like FOXP2 and SRGAP2 that fine-tuned neural development just enough to enable truly recursive language. Perhaps it was the population bottleneck that concentrated beneficial variants and created the conditions for rapid cultural evolution. Perhaps it was the exchange of genes and ideas when different human populations met and merged, combining their separate innovations into a more powerful whole. Most likely, it was all of these, and more. A perfect storm of biology, culture, crisis, and chance. But here is the revelation hidden in that ancient fire. The change wasn't finished then, and it isn't finished now. The cognitive revolution of 50,000 years ago wasn't a destination. It was an acceleration. We didn't arrive at some final form of humanity and then stop evolving. Instead, we became a species defined by continuous transformation, by the capacity to reimagine ourselves with each generation. The same neural architecture that let our ancestors imagine hunting strategies they'd never attempted also lets us imagine societies we've never built, technologies we've never invented, and futures we've never lived. The recursive thinking that created language and myth can also create new ethical frameworks, new forms of cooperation, and new relationships with the planet that sustains us. The symbolic mind that invented gods and nations can also recognize these as tools we created, and therefore tools we can redesign. This is the deeper meaning of the genetic whisper passed down through fire and famine. Consciousness is not just a mirror reflecting reality, but a force that shapes it. The imagination that was once survival's edge is now our only hope for navigating the maze of challenges we've created. Climate change, ecological collapse, nuclear weapons, artificial intelligence. These are all products of the same cognitive revolution. And they can only be solved by the same imagination that created them, turned toward different ends. The story of what changed 50,000 years ago matters not as ancient history, but as instruction manual. Our ancestors survived impossible odds not through strength or speed, but through flexibility, cooperation, innovation, and the ability to imagine alternatives to their current circumstances. They endured volcanic winters, ice ages, megafaunal extinctions, and the disappearance of every other human species because they could adapt faster than their environment could kill them. We face our own impossible odds now. Challenges of our own making, but challenges nonetheless. The question is whether we've retained the cognitive flexibility that defined our species at its emergence, or whether we've become trapped in rigid ideologies, comfortable narratives, and institutional inertia that our Pleistocene ancestors would never have tolerated because it would have meant death. The fire still burns. We still gather around it, though now it's the glow of screens rather than wood, the light of cities visible from space rather than small flames keeping darkness at bay. The stories we tell around these fires still shape reality, still determine who survives and who doesn't, still create the worlds we inhabit. What changed 50,000 years ago was the birth of a mind that could look at the world and ask, what if? What can change now is the answer we give to that question. The same cognitive tools that built civilization can reimagine it. The same symbolic thinking that created destructive myths can create regenerative ones. The same planning capacity that led us into planetary crisis can navigate us through it, if we choose to use it. That small band around the fire, watching their world burn, made a choice in the aftermath. They didn't give up. They didn't accept extinction. They imagined a future beyond the ashes and then walked toward it, carrying with them the genetic and cultural seeds of everything we've become. We are their descendants, inheritors of the most powerful cognitive toolkit evolution has ever produced. The whisper from that ancient fire still echoes in our neurons, in our myths, in our dreams. The question that haunts us from those flames isn't what happened then. It's what happens next. And unlike our ancestors, who could only react to catastrophes they didn't create, we have the dubious privilege of facing a crisis of our own making, which means we also have the power to unmake it. The cognitive revolution isn't over. It's waiting to see what we do next. The fire still burns, and the future is still unwritten. What we choose to imagine around these modern fires will determine whether the story that began 50,000 years ago continues for another chapter or ends in the very extinction our ancestors fought so hard to escape. The change is not behind us. It is in us. And what we choose to change now will echo as far into the future as those first symbolic scratches on African ochre echo into our present. The revolution continues. The only question is, will we be wise enough to guide it?